Good morning. So, very good morning to you. So, today we are discussing about one important topic we are discussing. So, once again, I am coming into the live. So, whoever writing TSPSC physics set, TSSET physics examination who are writing. For those people, I want to make one video. I assure to the people who are writing or aspirants to crack the TSSET physics examination. Last year exam paper 2023 exam paper we have to solve now because video may be length. Now this is the video, right? Once, please, I am humbly request to you, please share and subscribe our YouTube channel. Our YouTube channel for your edification of the physics knowledge and daily current affairs also available in our YouTube channel. Please concentrate and you have to utilize the chance. Clear? Now you have to see what is going to happen in this Quantum Online Academy. In Quantum Online Academy is providing now. So how many courses is providing? Once you have to see, Quantum Online Academy is providing more than 2-3 courses now it is running. Once you have to see, CSR and gate physics is started live plus recorded class every day 6 p.m. Sorry, 6 a.m. every day 6 a.m. to 8 a.m. there is a class is going on. CSIR and gate physics. Who are interested in CSIR and gate physics, go to our app, that is a Quantum Online Academy app, right? This is our symbol. You have to go to the Play Store. In your Play Store, it will be appear. You enter the Quantum Online Academy app. It will appear in your Play Store. You download it and you go through the stores. In stores, whatever the courses are is there, those courses you have to see. Now the course is running, CSR and gate physics course is running every day morning 6 a.m. to 8 a.m. There is a live class in app, not YouTube, in app, right? So please concentrate on this. Not only that, now Telangana government is giving job notification. In job notification, there is a degree college lecturer jobs are there. Degree college lecturer jobs, whether it may be Gurukulas or whether it may be uh, TSPSC or TGPSC, Telangana Public Service Commission. Maybe next year this notification it will come. While notification came after 45 days, they will conduct the exam. That's why you are unable to read the entire the DL portion, right? So now you take this class. This is very important class to you. DL physics examination, DL physics course also available in our app. We started the mathematical methods of physics. Once you go through the store and once you have to see our videos in our YouTube channel, you decide you have to join in the channel. You are qualified the set examination, you are qualified the net examination, you are completed their PhD. Those people are eligible to write the DL examination, right? You concentrate whether you want to put a target to long run. Long run means maybe next year June notification it will come, and September and October there will be exam is there. So that's why you have to concentrate on this. Clear? DL exam is there. Now if you want to take the DL or if you want to take a JL also you have to take. So these three courses are running now, right? Before going to the solve the 2023 CTS set paper, I am giving my information because of my YouTube channel is providing, not YouTube channel, my Quantum Online Academy app. Quantum Online Academy app from the Play Store you have to download here. If you have any doubt, you have to call my numbers 9908437460 630326 3368. So you call these numbers and you confirm, and you have to join in this course. So not only this one, once again you have to see, in future we ready to start the courses GS physics in English medium, only in English medium. There is no Telugu medium courses will available in our app, right? DSC physics content in English medium and Telugu medium. Maybe next DSC also will going to come. So that's why we started this course, DSC physics content in English medium. And IIT JAM and Central University entrance test PG physics. IIT JAM and Central University entrance test PG physics. Next academic year purpose, we started this course. UPSC mains physics optional. We were interested to the UPSC mains physics optional. Maybe next academic year we started this course. IIT JEE mains and advanced physics. IIT JEE mains and advanced physics course also we want to start. And NEET physics we want to start. These courses will be come soon. Within shortly it will appear. Maybe we have to start maybe next year 2025. From 2025 these courses will run. 2025 onwards these courses will run, right? So please concentrate on this first. Now the courses as is going on CSR and GATE, DL physics and JL physics. Once these courses will completed, after completion of these courses, we have to enter into the these remaining courses. Total 6 courses we need to start. GS physics in English medium, DS physics content in English medium, IIT JAM and Central Universities test PG entrance physics, UPSC mains physics optional, IIT JEE mains and advanced physics, NEET physics courses we want to start to you. Now once you have to see like this will appear in your app. So Quantum Online Academy app, CSR and GATE physics course. So that app symbol is Quantum Online Academy app. Go to the Play Store and you have to see the courses there. This course will be appear. CSR and GATE physics course will appear once you have to take this course. And DL physics also will appear. This one live plus recording classes. This is very important opportunity. Over not teach entire the year to you. Entire the year, complete whole portion I want to teach to you. You have to check whether sir is covering this topic or not. Also you have to check, no problem for me. So 1 year validity is there. You utilize this course, DL physics course. You have to utilize it. Is very important course. Wherever you go, any institute you go, you won't teach like me, right? Now you have to listen. JL physics course live plus recording classes also will appear. If you want to get the JL, because you don't have net, you don't have set, you don't have PhD, you are not eligible to write the DL examination. You have to join in the JL course also. Fees also very less compared to other institutes. And then general studies physics, it is very simplest course I started. If you want to start take the course, you have to stick. Now I am coming into the TS 2023. Which one paper it is? This paper is TSSET 2023. TSSET 2023 physics paper. TSSET 2023 physics paper. Now we are going to discuss. Total 100 questions are there. How many questions are there? Total 100 questions are there. These 100 questions we want to discuss. So question by question we want to discuss to you. Clear? I'm giving the information. Once again, I'm requesting you to you. So please share our channel to your friends. So please subscribe our channel and you make them subscribers in your neighborhoods, right? So that is my appeal. Now you have to see. The divergence of the vector field. The divergence of the vector field is equal to F is equal to 4x into I plus 3x y square into j plus xyz cube into k at the point 2 comma 2 comma 1 is what they are asking. Very simple. From vector analysis this question came. From where? This question is from mathematical methods of physics. Mathematical methods of physics. That is the first paper in your theory. Mathematical methods of physics from vector analysis. From vector analysis. This question area coming from vector analysis. Clear? Once I am giving the area, you able to see what are the areas are important. What they are asking, they are giving the data. F is equal to, they gave F is equal to 4x into I plus 3xy square into j plus xyz cube into k. This is the vector, force vector they are giving. What they are asking, the divergence of F, the divergence of F at particular point they are asking, at particular point 2 comma 2 comma 1 they are asking. First you have to calculate a divergence of F. Del is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Correct? I into dou by dou z plus dou by dou x plus j into dou by dou y plus k into dou by dou z dot, which one we have to write? 4x into I plus 3xy square into j plus xy z cube into k. Xy z cube into k. First you have to dot product you have to calculate. I dot I is equal to 1, I dot j is equal to 0, I dot k is equal to 0. Therefore, I dot I is equal to 1 means, so 4 into dou x by dou x is equal to 4 plus, so dou y you have to take 6xy plus dou by dou z is equal to, you have to take it as a 3xy z square, 3xy z square. First you have to put your limits. X is equal to 2, y is equal to 2 and z is equal to 1. You have to keep. X is equal to, there is no x here, so 4 plus, so 6 into 2 into 2, 6 into 2 into 2 plus 3 into 2 into 2 into 1 square. You have to substitute like this. So therefore you are getting, which one you have to get? Once you have to see here, 4 plus 6 4 ja 24, so plus how much value? 1 square means 1, 1 into 2 is equal to 2, 2 into 2 is equal to 4, 4 into 3 is equal to 12, right? So 12 plus 4 is equal to 16, 16 plus 24 is equal to, how much we are getting? 40. 16 plus 24 is equal to 40. What is your answer? Your answer is 3, 40 are there, right? So very simple is there. First you know the theory, what is the divergence, how we have to apply the divergence. If you know, it is simple to get this one. Clear? Like this question, from where it is coming? Mathematical methods of physics vector analysis question. This question is mathematical methods of physics vector analysis question. Now I am coming into the second question. Once you have to see the second question also, if x and y are two complex numbers, then which of the following is true? X and y are two complex numbers, which of the following is true? So this is a second question also. It is coming from mathematical methods of physics. Mathematical methods of physics. From mathematical methods of physics, this is a second question. Once you have to take the, which one it is? It is inequality. Inequality. Which area it is? This is the inequality rules or inequality laws. What are the inequality laws? Once you have to see, this question came from the inequality laws. Once you have to see, x, if x and y are two complex numbers, from complex numbers inequality, for complex analysis, this area is complex analysis. How important is there? Complex analysis, you have to go through inequalities in complex analysis. Before the question is vector analysis, now complex analysis inequality. If x and y are two complex numbers, then which of the following is true? Which of the following is true? So the modulus of x plus y, I am giving the one rule. So what is the rule is there? Modulus of x plus y is less than or equal to modulus of x plus modulus of y. So modulus of x minus y is greater than or equal to modulus of x minus modulus of y. This is the inequality rule. Whatever the rule is there here, that rule you have to see. Here third option is the correct ones you have to see here. Modulus of x plus y is less than or equal to modulus of x plus modulus of y. Modulus of x minus y is greater than or equal to modulus of x minus modulus of y. Which rule it is? It is a complex analysis inequality rule. Clear? From this we have to calculate the direct formula they are asking. How simple it is. Set examination once you have to see. Right? One more question you have to see here. The third question. So what is the third question once you have to see? The general heat conduction equation which gives the temperature distribution conduction heat flow in an isotropic solid reduced to Laplace equation, then the body is. The general heat equation. This is also a heat equation. Mathematical methods of physics. The third question also belongs to the mathematical methods of physics. Which area it is? Heat equation. Where is there heat equation? In advanced part of the CSIR. That advanced part of the CSR, partial differential equation. Partial differential equation. This area is partial differential equation. Right? From the partial differential equation, according to your syllabus, 3 topics are there. One is the heat equation, another one is the liquid flow rate equation and diffusion equation. So like that equations are there, Laplace equation, like that equations are there. So once you have to understood the question, the general heat conduction equation, which gives the temperature distribution conduction heat flow in an isotropic solid reduces to the Laplace equation when the body is, they are asking. Suppose if you have to see what is the general heat equation, once you have to take a general heat equation, I am writing here. Once you have to see, the general heat equation is del square T plus Q by K. Del square T plus Q by K is equal to 1 by alpha into dou T by dou T. For isotropic effect, for isotropic for a isotropic solid, if you have to take a isotropic solid, if solid is isotropic, which one we have to write? If solid is isotropic, dou T is equal to 0. So with respect to temperature is a constant, that property won't be changed. So therefore our heat equation we are changing, del square T plus Q by K is equal to 0. So this equation is which equation it is? It is a Poisson equation. Which one it is? Poisson equation. This equation is a Poisson equation with heat conduction. With heat conduction. Poisson equation with heat conduction. But what they are to get? We want to get a Laplace equation. Laplace equation when body. When it will be Laplace equation? If Q is equal to 0, then what will happen? This expression, if Q is equal to 0, del square T is equal to 0, it will come. This expression we call it as a Laplace equation. Which equation it is? This equation we call it as a Laplace equation without heat conduction. What we have to write? Without heat conduction. Laplace equation without heat conduction. Clear? So what is our option? Once you have to see, unsteady state with heat generation, not correct. Right? One more option you have to see, steady state with heat conduction, not correct. Unsteady state with no heat correction, not correct. Steady state with no heat generation. It is a steady state. Steady state means so dou T is equal to 0. This is the steady state, or which state it is? Isotropic state or steady state. And so del square T is equal to 0. Del square T is equal to 0 when it will come? Without heat generation. without heat generation. If we without heat generation, you are getting the del square, so T is equal to 0. Clear? Like this you will get the in your competitive exam. How simple it is there. Now you have to see. The order of convergence of the Newton-Raphson method, the order of conversion of the Newton-Raphson method. Suppose you have to see the Newton-Raphson method. So what is the Newton-Raphson method? Newton-Raphson method, you know, xn plus 1 is equal to xn plus 1 is equal to xn minus f of xn is divided by f dash xn. F of xn is divided by f dash xn. If you have to calculate the error of this, error of n plus 1 is proportional to whom? Is proportional to En square, it will come. This is the E means not energy. This is the error. Which one it is? Error. Therefore, which E square is a quadratic. Quadratic means the power is 2. Therefore, where it is convergent, the convergence under 2. Newton-Raphson formula converges under 2. If you have to calculate the error, you will get that one. From which area it is coming, once you have to see. This fourth question also we are getting from mathematical methods of physics. Mathematical methods of physics. Which area? It is a numerical analysis. Numerical analysis. This question is coming from the numerical analysis. Clear? This fourth question also coming from the numerical analysis. Clear? I will give some important data to you how to remember what data, this data you have to remember here. Suppose if you have to take a regular falsy method, you have to take the method, and here you have to take a convergence, order of convergence. Which one you have to write? Order of convergence. Order of convergence you have to take. Suppose if you have to take a regular falsy method, the order of conversion is equal to 1. Now you have to write a Newton-Raphson method. The order of conversion is equal to 2. The order of conversion is equal to 2. Now the third one you have to see. If you have to observe the secant method, right, the order of conversion is equal to 1.62. Secant method, the order of conversion is equal to 1.62. One more method you have to take, successive approximation method. The order of conversion is equal to 1. So these formulas you have to remember, otherwise these values you have to remember. Maybe direct you will get it in competitive examination, because set people are asking in theoretical mode. You have to remember that. If it is a regular falsy method, the order of convergence is equal to 1. If it is a Newton-Raphson method, the order of convergence is equal to 2. If it is a secant method, the order of convergence is equal to 1.62. If it is a successive approximation method, the order of convergence is equal to 1. If we want to solve the error, it will take so much of time. That's why I have to, I will teach 100 questions. That's why I'm wind up within the short. Don't keep in mind. Now we have to see the one more question, that is the fifth question, that is 55. 55 means fifth question. Once you have to take the fifth question. Fifth question also from mathematical methods of physics. From which area? Which area? It is a probability distribution. This area from the probability distribution. Probability distribution. Which area it is? This is from probability distribution. You have a basic probability and 3 probability distributions are there according to your curriculum. One is the Poisson distribution, second one is the normal distribution, another one is binomial distribution is there. Suppose if you have to take here, if n is the number of trials, what is the n? N is equal to number of trials. N, if you have to take N is a number of trials, N is the number of trials, and P is the probability of success. Probability of success. P is the probability of success. Once you have to take P is the probability of success. You consider the binomial distribution. Which distribution you have to consider? Binomial distribution. You have to consider a binomial distribution. Once you have to take the binomial distribution, what is the mean value? The mean value for a binomial distribution is equal to what is that? A number of trials into probability of success. This is the formula only. The mean value of binomial distribution. The mean value of binomial distribution is equal to N into P. Direct formula they are giving. Once you have to see N into P is the correct answer. Correct? So you have to see the probability distribution. Only 3 probabilities are there. That question bakka it will come. If you have to learn the 3 probabilities, binomial probability distribution, Poisson distribution, and normal distribution is there. So now our importance is there once you have to see. Right? Next, 6th question, you have to take the 6th question. The value of j 1 by 2. This is the Bessel function is there. This one also mathematical methods of physics. The 6th question also mathematical methods of physics. This question from special functions. Special functions. This question from which area? Special functions. Once you have to see the special functions according to your curriculum, 4 special functions are there. One is legendary special functions, legendaries. The second one is Hermite polynomials, Hermite's functions. The third one is Lagrange polynomial, Lagrange polynomial, Lagrange's polynomial. The fifth one is Bessel's, fourth one is Bessel's polynomial or Bessel's function. Right? This question came from the Bessel polynomial only. So j is a Bessel polynomial. J 1 by 2 of x is equal to, there is a formula only, root 2 by 5x into sin x. This is the formula, like that you have to remember. J 1 by 2, J 1 by 2 x is equal to root 2 by x into sin x. This is very, very important. Which answer is correct? Answer 2 is correct. From which area it is coming? From special functions, mathematicals of physics only. Question number 6 also we are getting from the mathematical methods of physics only. Now we have to see the 7th question. The central limit theorem states that, the statement of the central limit theorem in the core of the CSIR syllabus, this is the last topic. Central limit theorem is the last topic. The 7th question also you are getting from the mathematical methods of physics. From which area? It is a central limit theorem. Central limit theorem. Central limit theorem. That statement itself they are asking. Nothing they are asking. Only statement only. If sample sizing increases, the sampling distribution must approaches the normal distribution. It is also probability theory only. It is also under the probability theory. Probability theory. Under the probability theory only they make the question. So what is the answer? Once you have to see, if you increase the sampling distribution if you have to increase, it will goes to becomes the normal distribution. So normal distribution, how we have to calculate the normal distribution? That normal distribution Zn is equal to, normal distribution Zn is equal to, if you have to see, xn minus mu is divided by, xn minus mu is divided by sigma by root n is there. If you have to use a sampling size is more and more, then this central limit theorem, sampling size increases, it must be approaches to normal distribution. That answer is correct. Now this is the which question it is? 7th question it is. Now you have to see the 8th question. You have to see 8th also from the mathematical methods of physics. Mathematical methods of physics. From which area? It is a complex analysis one. This one also from complex analysis. From complex analysis, how many questions are coming? Once you have to see what is the importance of that complex. Which of the following function f of x of a complex variable is not analytic all the points of complex plane? So among that, e power x, what is the analytical function? A function is a analytical function, there is a formula is there. If it is analytical function, there is a formula is there. What are those formula? Dou u by dou x is equal to, dou u by dou x is equal to dou v by dou y, and dou v by dou y is equal to minus dou u by dou x. So under this formula, these equations we call it as a Cauchy-Riemann equations. This equation we call it as a Cauchy-Riemann equations. Which equations? These equations we call it as a Cauchy-Riemann equation. If these one satisfied this equation, then that function we call it as a analytical function. So which of the following f of x is a complex variable, is not analytical all points of the complex plane? F of x is a infinite series, sin x is the infinite series, cos x is a infinite series, but f of x is equal to log x is not infinite series. So that's why this is not analytical function. Not analytical function. Analytical, not analytical function, right? If you have to take this one is a not analytical function. Please concentrate on this. Both three are infinite series are there, but f of x is log x is not infinite series. Now one more question is there. Once you have to see the functions in Green's theorem. Where is there in Green's theorem in mathematical methods of physics? The question number 9 also coming from the mathematical methods of physics. This is the Green's theorem. Green's theorem's question. Green's theorem. Why I am writing all these things? You concentrate on these areas. You will get these areas a very important whenever you have to go to the competitive examination. Green's theorem question is coming from the mathematical methods of physics. Where it is there? It is the advanced part of TSSET syllabus or CSIR syllabus. TSSET and CSIR same syllabus is there. Syllabus is not varying, but question is varying. The function in Green's theorem are mathematically continuously derivative, not correct. So this Green's theorem is continuously partial derivative, continuously partial derivative. This Green's theorem is continuously partial derivative theorem. Partial derivative theorem. Therefore, once you have to see the answer, it is a continuous partial derivative theorem. This Green's theorem is continuous partial derivative theorem. This is very important theorem. Please concentrate on this. Right? That is also mathematical methods of physics. How many? Till now 8, 9. Now 10th one is there. So 10th one also same. Once you have to take the 10th question also, the final character of the fourth order Range-Kutta method uses. This is also coming from the mathematical methods of physics. From which area? It is from numerical methods. Numerical methods. This question came from the numerical methods only. What they are asking? The final character of the fourth order of Range-Kutta method. Fourth order of the Range-Kutta method. So two characters are there. So what are the characters? Once you have to see, the final character is Simpson's rules. Simpson's rules. The final character is Simpson's rules, right? The final character, it is the final character. We call it as we have to follow the Simpson's rule. There is one more character is there, midpoint character. That midpoint character is, so which rule it is? That this character is the third character. Midpoint character is the third character, right? Third character. The final character is a Simpson's rule. That midpoint character is the third character. There is a predictors also is there. They are not asking the predictors, they are asking the characters only. Which one is the final character? Simpson's rules are final characters are there. Please remember that one. Now this is also 10th question also from mathematical methods of physics. Same you have to see the number of intervals in the Simpson's 1/3 rule. This is also same. Now you have to see this question is the 11th question from mathematical methods of physics. Which area? This area is from numerical methods. Area is from numerical methods. Mathematical numerical methods. Numerical methods. Clear? Right? This is the area from the numerical methods. Mathematical physics question only. Simpson's 1/3 rule. What is the Simpson's 1/3 rule? It is a approximation integral a to b f dx is equal to integral a to b f of x dx is equal to h by 3 into which one we have to write? F of we have to take it as a f of x0 plus 4 into f of x1 plus 2 into f of x2 plus 2 into f of x2 plus and so on plus 2 into f of x n minus 2 into f of x minus n minus 2 plus 4 into f of x n minus 1 plus which one we have to write? F of xn bracket close. This is the Simpson's 1/3 rule. In the Simpson's 1/3 rule, h is equal to b minus a by n. What are the n? So these are the intervals. Intervals must be equal to even number under the Simpson's rules. So Simpson 1/3 rule, that intervals must be even numbers. How many intervals are there within the bracket? Those intervals must be even intervals is there. Always, not must be. Intervals always even numbers. Even intervals we have to take. This is also from mathematical methods of physics, numerical methods. The Lagrange's interpolation method, Lagrange 12th question. The 12th question also came from the mathematical methods of physics. From which area? It is also from the numerical methods. Numerical methods. How many questions are coming from the numerical methods? Once you have to see mathematical methods of physics only. Lagrange interpolation relation. There is a Lagrange interpolation method can be used for both equal intervals and unequal intervals. Both intervals we are using Lagrange interpolation rule. Lagrange interpolation rule we can use both equal and unequal intervals we have to use. This 12th one also from the mathematical methods of physics only. Now the 13th one you have to see. What is the 13th one? 13th one also from the mathematical methods of physics. Which area it is? The most unstable average. The most unstable average means it is also coming from the probability theory. Probability theory, right? Which area it is? It is the probability theory. This question came from the probability theory. The most unstable average is mode, right? We are taking the most geometrical mean, median. So geometrical mean, there is a structure is there. Mean also there is a structure and formula is there. But median also there is a structure and formula is there. But mode is not structure and formula. This average we call it as a most unstable average. Most unstable average. Most unstable average is a, which one it is? That is the mode is the most unstable average. Clear? This is very, very important. Please concentrate on this. So not only this, 13 questions came from the mathematical methods of physics. Some more questions will be added in 100 question theory. You have to see what are the questions are there in the latter. You have to see. Now I am coming into I am coming into the 14th question. If the force applied to a body is doubled, if the force, this question coming from the classical mechanics, which area? From Newton's laws. From Newton's laws. In the classical mechanics, there is a theory is there. In the Newton's laws, the question is coming once you have to see. If the force is applied to the body is doubled. If the force is applied to the body is doubled means 2F. And mass is off. And mass is off. M is equal to M by 2. Then the acceleration of the ratio, how much they are asking. Then what they are asking? Acceleration of the ratio they are asking. F is equal to ma. There is a formula is there. F is equal to ma. How to do here? So because here space is there, once you have to take. Once I will take the another boards, after the under slides it won't support. So that's why problem I have to write here only. Once you have to see. The force is doubled. Here force is 2F and mass is equal to half. M is equal to M by 2. I am applying the Newton's second law. F is equal to ma. F1 by F2 is equal to M1 by M2. M1 by M2 into A1 by A2. I am writing based on those formula. How to write like this. So now you have to substitute. F1 is equal to F, you have to take F2 is equal to 2F, and so is equal to, you have to write here is equal to M1 is equal to M2 is equal to M by 2, A1 is equal to A2. The acceleration ratios they are asking. Clear? So now you cancel it, M, F, you have to cancel it. 1 by 2 is equal to, so it will come 2 by 1 is equal to A1 by A2. So into A1 by A2. So therefore this multiplication will come to this side. 1 by 2 into 1 by 2 is equal to A1 by A2. So therefore which one we have to write? A1 is to A2 is equal to 1 is to 4 is there. What is the ratio of the acceleration? What is the ratio of the acceleration? How simple is there? They are asking based on the Newton's second law. Whoever knows, unknown people also. Unknown people means layman of the physics also can do this question. This question came from the Newton's second law. Clear? Like this you have to do. Now the mass of the body is 2 kg, right? This is also the second question from classical mechanics only. This second question also belongs to which area? Classical mechanics only. This is also from which area? Once you have to see. The mass of a body is 2 kg and is moving on a horizontal surface with a velocity 4 meter per second, but comes to the rest after 2 seconds. If one wants to body to move with the same initial velocity, the force to be applied, it is force to be applied. It is a kinematics. Maybe you have to learn in the 9th class and 8th class also. There is a kinematics rules are there. From that they are asking this question. The mass of the body is equal to 2 kg. The mass of the body is equal to 2 kg and is moving horizontal surface with the velocity, 4 meter per second, but comes to the rest after 2 seconds. Comes to the rest means V is equal to 0 when after 2 seconds. After 2 seconds, so V is equal to 0. If one wants to the body to move with the same initial velocity, the force is to be applied. If one wants to the body with smooth same initial velocity, the force is applied, then they are asking. First we have to calculate the acceleration due to this area. V is equal to u plus at, correct? V is equal to 0, u is equal to 4, plus a we don't know, t is equal to 2 seconds are there. So therefore a is equal to minus 4 by 2 is equal to minus 2 is there, but you have to take, this is the minus is the direction, 2 meter per second square. This is the acceleration unit, right? Now what they are asking? They are asking the force. Force F is equal to ma. with the same initial velocity, m is equal to 2, we are getting the 2, 4, so newtons we are getting. What is the answer? 4 Newton. Like this we have to calculate. Just kinematics and Newton's laws I am applying, and I am getting the question may be lengthy, but if you have to follow, those answers are very, very easy once you have to see. This is the second question from the classical mechanics. Now the third question you have to see, it is also from the Poisson bracket. Third question also from classical mechanics. Which one it is? Third question also from classical mechanics, correct? Classical mechanics question only. From which area? Poisson bracket. Already you know the Poisson bracket. Which area it is? A Poisson bracket. Poisson bracket is very, very important in competitive examination. Why I am writing this area? These areas you have to read and you go for the examination. You will crack the exam. At least you have to see the brief idea. At formulas also at least you have to see. You will get the perfection in your examination. Clear? Classical mechanics from the Poisson bracket. What is the Poisson bracket? In the Jacobi identity, in a Poisson bracket, one identity is there. That identity we call it as a Jacobi identity. What is a Jacobi identity? Once you have to see here. So P comma Poisson bracket P comma Poisson bracket Q comma R, Poisson bracket Q comma R plus Poisson bracket Q comma Poisson bracket so R comma P, Poisson bracket R comma P plus Poisson bracket R comma Poisson bracket R comma Poisson bracket P comma Q is equal to 0. This is the it is identity rule. Which rule it? This rule we call it as a Jacobi identity rule. What they are asking? They are asking about the P comma Q comma R. So as it easily is there, P comma Q comma R, as it easily is there. As it easily I am keeping. Now you have to see minus P comma Q. Minus P comma Q means you have to exchange these terms. It will become as a minus P comma Q into R. Minus P comma Q into R we have to write. Poisson bracket R is equal to what they are asking. Is equal to, we have to write here, minus if it is goes to this side, minus Q comma R comma P, minus Q comma R comma. How we have to take the minus? You have to eliminate. What we have to write? We have to write Poisson bracket R comma P comma Poisson bracket Q we have to write. This is your answer. How simple it is there. If you know the Jacobi identity, you have to rearrange then, so you will get the answer. What is the answer? R comma P, Poisson bracket R comma P comma Q is the answer. Like this you have to calculate. This question came from the third question from a classical mechanics. Third question from classical mechanics, that very, very important and easy question. Once again you have to see one more question, right? This is also classical mechanics question only. Fourth question also belongs to the classical mechanics question. From which area? It is a degree of freedom. So there is a degree of freedom is there. A degree of freedom is there in your syllabus. From that syllabus we got the question. What is the question? Once you have to see in a hour's hand. Suppose you have to take a clock. This is the clock is there, 12 and 6. You have to consider as which one we have to consider, and 3 and 9 you have to consider. So there is a hand is there. Which hand it is? Hour's hand is there. There is a hour's hand. Suppose if you have to take a simple pendulum, in olden days a simple pendulum is rotating like this. You have to fix it with one ball and you rotate the bob and it will rotate, and to and fro motion is there. It is also whether it may be clockwise, whether it may be anti-clockwise direction. So this anti-clockwise direction, in the clockwise direction it should be rotated. What is the degree of the freedom of the hands of that? Degree of freedom of the hands of that, it is exactly similar to the simple pole. What is the degree of freedom? The degree of freedom of hands hands, hours hands, hours hands, hours hands of clock, hours hands of clock is equal to 1. You have to remember this. The degree of freedom of hours hands of clock is equal to how much? 1. It is a classical mechanics question. Now, once you have to see the D'Alembert's principle and principle of virtual work. The D'Alembert's principle and principle of virtual work. This is also under a classical mechanics question only. That is the fifth question from the classical mechanics. From which area? D'Alembert's principle. There is a quoted syllabus is there. D'Alembert's principle. Which area it is? This area we call it as a D'Alembert's principle. This area is very, very important to crack the competitive exam. What is the virtual work of the D'Alembert's principle? Virtual work W is equal to summation of we have to write here work is equal to F dot S only, no? For we have to take a actual force minus the rate of change of momentum into delta Ri. This is the, which one it is? This work is a rest. Which one it is? It is a rest of the virtual work. And this one we call it as a, which one it is? Motion. It is a momentum means under the motion, right? So therefore what we have to write in the D'Alembert's principle, one is virtual, one is the rest is there. So therefore what we have to do, both are the same. One exists in another never. One for the motion, this one is correct, third one, and other for the rest. One for the motion and other for the rest. So the principle of virtual work, so you have to take it as a W. So this one is actual, it is rest, and so this one is the motion is there. Suppose you have to take F actual minus Pi dot Ri is there, Pi dot, that is also work is there. So two are there, two components are there. One is the rest, another one is the motion. So that is very, very important. You have to concentrate that one. So what is that question number? Fifth question in classical mechanics. Now you have to see here. So the sixth question also belongs to the classical mechanics only. The sixth one also belongs to the classical mechanics. Sixth one means under the classical mechanics it is a 6. The dynamics of a particle governed by Lagrangian. So Lagrangian is equal to, they are giving 1 by, it is a Lagrangian and Hamiltonian. In classical mechanics, without Lagrangian and Hamiltonian, there is no question paper. Lagrangian mechanics or Lagrangian theory, right? Lagrangian theory and Hamiltonian theory is very, very important. 1 by 2 m x dot square minus 1 by 2 kx square. This is a Lagrangian. You have to take Lagrangian. L is equal to kinetic energy minus potential energy. This is the basic formula of the Lagrangian. The dynamics of a particle governed by the Lagrangian describes. Lagrangian describes which particle? A free particle, it is not correct. A damped harmonic oscillator, it is not correct. An undamped harmonic oscillator with time dependent frequency, not correct. A undamped simple harmonic oscillator will give the Lagrangian. Undamped simple harmonic oscillator, because so many Lagrangian applications also is there for a simple pole, for a rigid rotator, for earth sun system. Lagrangian, you have to write all the things and you remember any one bit will come. So this one is undamped simple harmonic oscillator. That is the question. Now you have to see classical mechanics. This is the seventh question under classical mechanics. Seventh question under classical mechanics. Which area you have to see? When an elevator is a stationary coin dropped from the height h, this is also from the Newtonian mechanics only. Newtonian, which one it is? Newtonian mechanics. Which mechanics it is? Newtonian mechanics. Newtonian mechanics we are asking, classical mechanics question only. When an elevator is stationary, if you have to take, when an elevator is stationary, a coin dropped from height, a coin dropped from height, an elevator is stationary. Suppose you have to take one lift. So this is the lift or elevator. Everybody go the lift, because in Hyderabad shopping malls also. So there one lift is there. Once you have to see here, what is the thing? One one elevator is stationary, a coin dropped from height h, one coin is dropped from height h, reaches the floor in its time t1. This time we call it as a t1 is equal to square root of one formula is there. So that formula is so which formula you have to take it as a square 2h by g. Maybe it is 8th class formula only. T1 is equal to 2 time to take the ground. So from the maximum height, this is the T1. Now, if the elevator is moves uniformly with the same kind, the elevator is moves with same kind, it is moving 2h by g plus a. This is the T2. So same height reaches the floor on time T2. Then which of the following is correct? They are asking. Once you have to see, elevator is stationary. A coin dropped from the height h. The reaches that floor the time T1. If the elevator is moves uniformly, the same coin is dropped from elevator is uniformly same kind is dropped from the floor through the lift. What will happen? But in the lift, acceleration is equal to 0. You have to know lift acceleration is equal to 0. So therefore T2 is equal to, also we have to take it as it is a 0. So it is also gaining 2h by g only you are getting. So therefore what we have to write, T1 is equal to T2. T1 is equal to T2. Your answer is correct. T1 is equal to T2. It is also from the Newtonian mechanics question only. Now the 8th question, there is a mismatch is there. They will get the marks for all the people. The Poisson brackets, they are asking the Poisson bracket only. So they are asking the Poisson bracket. You have to see the area. Poisson brackets. So for the Poisson brackets only question is coming. So the Poisson bracket x comma apx minus ypz plus bz square is equal to where a and b are constants. So they are asking, but everyone get the question. This question belongs to the Poisson bracket. This question, some mismatch is there. We are unable to solve this question. But if we solve also, we are not getting these answers. So that's why you leave that one. Clear? Now you have to see the relation between the which area it is. That question, 8th question from the Poisson bracket. This question is the 9th question. You have to see from classical mechanics only. 9th question also from classical mechanics only. We have to ask that 9th question. You have to see what is that 9th question. You have to take from the classical mechanics. 9th question also from classical mechanics. The relation between the phase velocity and group velocity, they are asking. The relation between the phase velocity and group velocity. Once you have to see how we have to call group velocity and phase velocity. Group velocity and phase velocity. Group velocity and phase velocity. That area is the group velocity and phase velocity. Once you have to take here, which one you have to see. There is a group velocity formula, Vg is equal to d omega by dk. But Vp is equal to, there is a phase velocity is there. What is that phase velocity? Omega by k, phase velocity. So therefore omega is equal to k into Vp, we have to write. So k into Vp. But here you have to see the relation between the phase velocity, they are taking as a Vp is equal to u. K into u you have to write. The group velocity, the same notation they are giving. Once you have to substituted, so Vg is equal to d by dk of u is equal to, which one we have to write? Omega is equal to u into k. You have to differentiate with respect to u comma uv method. So u into dk by dk plus k into du by dk. Therefore dk get cancelled. U plus k into du by dk. This is the relation between the group velocity and phase velocity, where u is which one it is? Phase velocity. According to their notation I am giving. So you have to see G is equal to u plus k into du by dt dk. This is the your correct answer. Clear? So that is very, very important. This is the classical mechanics group velocity and phase velocity they are asking. Now the 10th question you have to see. What is the 10th question? So the 10th question is 10th question also belongs to the classical mechanics. Classical mechanics, under the classical mechanics, this one is a 10th question from special theory of relativity. So this question came special theory of relativity. Special theory of relativity. STR means special theory of relativity. Special theory of relativity. Special theory of relativity. Clear? Right. 10th question also classical mechanics from special theory of relativity they are asking. Once you have to see, if the kinetic energy of the particle is equal to rest mass energy, if kinetic energy of the particle is equal to rest mass energy, E kinetic energy is equal to E naught is the rest mass energy, then the speed of the light is equal to how much they are asking, then the speed of the light. But you know one principle. What is the principle? You know, the kinetic energy is equal to total energy minus rest mass energy. Correct? Now the kinetic energy is equal to total energy is equal to gamma into E naught in terms of rest mass energy. We have to write the kinetic energy is equal to E naught according to the data is equal to gamma minus 1 into E naught if you have to take the common. So what will happen is equal to gamma minus 1. So therefore gamma is equal to which one we have to write 1 plus 1 is equal to 2. Gamma is the ratio of 1 by square root of 1 minus v square by c square. So is equal to 2. So therefore what we have to write 1 by 2 is equal to square root of 1 minus v square by c square. If you want to eliminate the root, you have to square on both sides. So then 1 by 4 is equal to which one we have to write 1 minus v square by c square. So therefore v square by c square is equal to 1 minus 1 by 4 is equal to 3 by 4 is there. V square by c square is equal to, so v square is equal to, we have to write is a 3 by 4 into c square. V is equal to root 3 by 4 into c. So therefore what we have to write root 3 by 2 into c. This is the speed of that particular part. What is the speed of that particular part? Root 3 by 2 into c. Like this we have to solve. If you know the formula, how we have to solve the problem, you know the problem solving skill, then it is easy to identify the answer. Clear? So that is the your correct option you have to see. It is a 10th question under classical mechanics only. Now you have to see the 11th question. This 11th question also from classical mechanics only. It is which one? It is symmetric bodies under symmetric bodies or rigid bodies. You have to take it as a rigid body also. Rigid bodies, one topic is there. From that topic they are asking that. So if I1 is equal to, there is a rule is there, the variety of the bodies and types of the bodies once you have to consider. So types of bodies once you have to see how many types of bodies are there. You have to take a types of bodies. So 4 varieties of the bodies are there in the rigid body dynamics. One is you have to take it as a symmetrical top. The first one you have to take it is a symmetrical top. Symmetrical top is the first one. The second one, if you have to consider, what is the second one? Asymmetrical body. Asymmetrical body. The second one is the asymmetrical body. The third one is spherical body. The third one is the spherical body. And the fourth one is the last one. That is the fourth one is rigid rotor or rigid body or rigid rotor. Rigid body or rigid rotor. If it is asymmetrical, which one we have to write here? It is a symmetrical top. I1, moment of inertia, I1 is equal to I2 is not equal to I3. I1 is equal to I2 is not equal to I3, then we call it as a symmetrical top. Whether what is asymmetrical? I1 is not equal to I2 is not equal to I3, then we call it as asymmetrical. So what is the spherical? I1 is equal to I1 is equal to I2 is equal to I3, which is a spherical. what is the rigid rotor? I1 is equal to I2, but I3 is equal to 0. I1 is equal to I2 and I3 is equal to 0. Such type of relation we call it as a rigid rotor. According to your, so once you have to see I1 is equal to I2 is not equal to I3, which it is? It is a symmetrical top. Which one it is? Symmetrical top. Clear? Classical mechanics under rigid body dynamics the question came. This is the 11th question. Now you have to see the 12th question. What is the 12th question? Once you have to take the rank of the moment of inertia. It is also from classical mechanics. There is a moment of inertia topic is there in classical mechanics syllabus. From the moment of inertia, from moment of inertia, moment of inertia vector is there. I is equal to ixx, ixy, ixz, iyx, iyy, iyz, izx, izy, izz. There is a moment of inertia, vector. So what is the rank of this moment of inertia vector? The moment of inertia vector rank is equal to 2. This, if you have to calculate the rank, so rank is equal to, what is the rank? 2 is the rank of this vector. How we have to calculate the rank? Go for the mathematical methods of physics. Otherwise you have to see also here also. Now this one is a 12th question. Now you have to see this is the 13th question. The 13th question also under classical mechanics only. This question also belongs to the special theory of relativity. Special theory of relativity. Which area it is? Special theory of relativity only. This area also special theory of relativity only. Suppose you have to see there is a 3 variations are there according to the Einstein. That is the beauty of the special theory of relativity. The first theory is the length contraction. The second one is the time dilation, and the third one is the mass variation. Right? These 3 variations are there. Suppose my length is maybe 5.6 feet is there. If I have to go with the light velocity, what will happen? My length should be contracted. 5.6 should be so decreased. So my time, if you time also elongated like that is there. Suppose you are that concept you may know, you may not know. That is the theory is existing now. The contract length of a rod, the contract length of rod 90 percentage. Which length it is? The contract length of rod is equal to 90 percentage, 95 percentage. L is equal to 95 percentage of its original length. 95 percentage of L naught. The speed of the speed of rod relative to observer they are asking. The speed of rod V is equal to how much they are asking. Clear? Now once you have to see what is the length contraction principle. What length contraction principle, once you have to take length contraction, Einstein length contraction principle is equal to L is equal to L naught by gamma. L is equal to L naught by gamma. So therefore L is equal to L naught is divided by gamma is equal to square root of 1 minus V square by C square. Then you have to substitute here. L is equal to L naught into square root of 1 minus V square by C square. L is equal to how much is there? You have to see L is equal to 95 percentage means 0.95 L naught is equal to L naught into square root of 1 minus V square by C square. Square root of 1 minus V square by C square. L naught get cancelled. 0.95 whole square is equal to 1 minus V square by C square. Therefore, V square by C square is equal to 1 minus 0.95 whole square. Therefore, V square is equal to 1 minus 0.95 whole square is divided by, so 0.95 whole square is a whole square into C square is there. So therefore, V is equal to square root of 1 minus 0.95 whole square, 1 minus 0.95 whole square into C square is equal to C.
1 minus 0.95 is equal to 1 minus 0.95, 0.5 whole square into C. 0.5 whole square into C is there. So you have to take 0.5 whole square in, you have to take it as 0.9. 1 minus, oh sorry, this is not that one. So square is there for this one only, 0.95 into C. You calculate this, you will get 0.3 C you are getting once you have to calculate this one. So this is your answer. 0.3 is your answer. 0.3 C your answer. Like this you have to calculate. Now how many questions are there from classical mechanics? 13 questions from classical mechanics. See how the importance of, they are asking, the variation will be changed. So till now 13 questions from mathematical methods of physics I told, right? So 13 questions from classical mechanics I told. 13 questions from mathematical methods of physics and 13 questions total. 26 questions are there. If you want to crack the exam, entire the syllabus you won't want to read. Whatever the papers, 9 papers are there. Within the 9 papers, at least 6 papers you have to read, and you will get it more than 70% of the exam paper. Clear? So entire all the papers you unable to read also. If you read, that is the fine. To crack the exam, 50% you have to get it, as that is very very overcome the exam only. Clear? Now 1 hour finished, only 26 questions I told. So I will make a fast, try to understand, because 100 questions I want to make the video. This is the live session. This session is a live session. I cannot take the breathe, and I cannot take the which one it is, whatever it may be, according to you only I want to teach to you. So for your sake only I am teaching to you. Please utilize this chance, utilize the areas also you have to utilize. So that's why I am writing the areas also. Now you have to see which one it is. 77th question. What is the 77th question? That question is under which one it is, you have to see under electromagnetic theory question. Which question it is? Electromagnetic theory question. Question you have to read here. The electric field and the magnetic field associated with the magnetic vector potential. The electric field and the magnetic field associated with the, this one is a first question under electromagnetic theory. Electromagnetic theory, magnetic vector potential. Magnetic vector potential. This one very very important, magnetic vector potential. Under the magnetic vector potential, this question came, right? Electromagnetic theory. In electromagnetic theory, this question is the first question. Once you have to see what they are asking. You know the electromagnetic potential is a way, it is also vector. They are asking in terms of A, E and B in terms of A they are asking. So B is equal to, you know, del cross A, E is equal to minus 1 by C into dou A by dou T. There are the formulas are there. H is equal to minus del cross A. So H is equal to plus del cross A. Actually B is equal to del cross A, but H also del cross A you have to write. So notation is differently they are asking. These are the formulas only. You have to remember E is equal to 1 minus 1 by C into dou A by dou T. H is equal to del cross A. Clear? This is the first question under electromagnetic theory. Now the second question you have to see. What are the second question once you have to take? If two thin parallel wires, if you have, this is also electromagnetic theory question. Electromagnetic theory. So this question came from the magnetostatistics. Magnetostatistics. Magnetostatistics or statics. Magnetostatics. 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 So magnetostatics. So this question came from the magnetostatics. If two wires, suppose you have to take two wires is there. This is one wire and this is another wire. If two thin parallel wires carrying the currents in opposite direction, so carrying the current, one is current is flowing in this direction, I1 current is going in this direction, I2 current is going in the opposite direction. Please remember, if two parallel wires carrying in opposite direction, there is a which force is there in between. So there is a force is there, that force is opposite direction is there, then the force between repulsive force. The force is repulsive. The force is repulsive force. If it is going in the same direction, that is a attractive force. That repulsive force, where it is acting, it is 90 degrees to that parallel line. If the two thin parallel wires carrying the current in opposite direction, then the force experienced due to the other, the force experienced due to the other is, what is that? Perpendicular to the lines, that is repulsive. Perpendicular to the lines, and that is the repulsive. Very, very important. That is the basic theory question only they are asking. Clear? Now you have to see here, first EM theory, second EM theory question. The third EM theory question you have to see. This is also third EM theory question. Third one also from the EM theory they are asking. What is the question? Once you have to see from the electromagnetic waves. Electromagnetic theory for EM, electrodynamics. Electrodynamics you have to see here. Electrodynamics, which area it is? It is coming under the electrodynamics, electromagnetic theory or electrodynamics. Here electric field and magnetic field mixing is there, so that's why we call it as the electromagnetic theory they are asking. If the speed of the electromagnetic wave in the medium is, the speed is equal to, how much speed is equal to 1.5 into 10 to the power of 10 meter per second. This is the speed of the electromagnetic wave in the medium is equal to 1.5 into 10 to the power of 10. Then the refractive index of the medium, is equal to, how much they are asking? They are giving the speed 3 into 10 to the power of 10 meter per second. So the 10 meter per second. This is very, very important. There is a relation is there. Refractive index is equal to the speed of light is divided by the speed in the medium. Now you have to substitute n is equal to the speed of light 3 into 10 to the power of 10. So meter per second is divided by v is equal to 1.5 into 10 to the power of 10. So 10 to the power of 10, 10 to the power of 10 get cancelled. Now what will happen? 0.2. 3 is divided by 15 is equal to, how much we are getting? So we are getting the value. So that answer is 0.2. Option A is correct. All options they are giving, once you have to see, is not correct, is not correct, is not correct. So option A is 0.2. We have to take 0.2 you are getting now. So 2 you are getting. Clear? Once again you have to see here, 1.5 means by 10 means 30 is divided by 15. So 15 1 ja, 15 2 ja. 2 you have to get the answer. So 2 is a correct answer. Sorry, 2 is the correct answer. Like this you have to calculate. But all options are not correct. So 2 is correct. Electromagnetic theory, third question this is. Now one more question you have to see. This is also from the electromagnetic theory. From the electromagnetic theory, this is a fourth question. Electromagnetic theory, fourth question. If a plane wave in the free space is normally incident, suppose you have to take a plane wave you have to consider electromagnetic wave. A plane electromagnetic wave in a free space normally incident, this is a infinitely thick sheet, infinitely thick dielectric slab. Which one it is? Infinitely thick dielectric slab. Infinitely thick dielectric slab you have to take. Infinitely thick dielectric slab you have to consider, right? Then the magnitude of the reflection coefficient. Then the magnitude of the reflection coefficient, the dielectric constant they are giving, epsilon r is equal to 9. This is the dielectric constant. Then they are asking the reflection coefficient. What is the reflection coefficient? There is a formula is there for the direct 1 by square root of epsilon r minus 1 by square root of epsilon r plus 1. This is the relation between the dielectric constant with respect to the reflection coefficient. R is equal to, just you have to substitute 1 by 3 minus 1 is divided by 1 by 3 plus 1. 1 by 3 minus 1 is equal to minus, so 2 by 3 is divided by minus 2 by 3 is divided by 1 by 3. So minus 2 by 3 is divided by 4 by 3. 3 3 get cancelled. So 2 1 ja, 2 2 ja. Therefore, minus 1 by 2 is equal to 0.5. Why I am getting the minus? Minus shows it is a reflection. Reflection. Minus shows for the reflection. 0.5. That is the fourth question from the which area it is? Electromagnetic theory. It is also area from the electrostatistics and electrodynamics. 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 This question also coming from the electrodynamics only. It is a mixing from the electromagnetic theory only. You have to see how simple you have to take. Now the following two parameters same in the conductor. Once you have to take the conductor, the following two parameters are same, they are asking. The following two parameters same in the conductor is equal to, so what is the same in the conductor? Once you have to take the propagation constant. The propagation constant gamma is equal to, what is this gamma? Gamma is a propagation constant. This is also electromagnetic theory. Which question it is? This question belongs to, you have to see here, this question belongs to, sorry, right. Once you have to take here, which one it is? Fourth one completed, no? The fifth one under electromagnetic theory. Fifth one under electromagnetic theory. This question belongs to which area? This question belongs to the electrodynamics only. Electrodynamics. This question belongs to which area it is? This question also belongs to the electrodynamics. Clear? This question belongs to the electrodynamics is there, right? Electrodynamics only. The propagation constant, propagation constant is equal to, we have to write alpha plus I beta, where alpha is a phase constant, alpha is the phase constant, and beta is equal to attenuation constant. Beta is equal to attenuation constant. Alpha is the phase constant and beta is a attenuation constant. How we have to write the alpha and beta? Once you have to see, alpha is the phase constant and beta is a attenuation constant. How we have to derive this one? Once you have to see here, gamma is equal to, now we have to write, once you have to see, gamma is equal to alpha plus I into beta. But gamma gamma propagation constant, you know, the propagation constant is equal to, one formula is there, that is square root of j into mu omega, j into mu omega into, so j into mu omega, into, so sigma plus I, sigma plus j omega epsilon, this is the formula for a propagation constant. From this formula you have to take the common, from which one you have to take the common? Omega mu, you have to take the common, j omega epsilon you have to take the common. Which one you have to take the common? J omega epsilon you have to take the common. A sigma is divided by j omega epsilon plus 1. Sigma is divided by j omega epsilon plus 1. Therefore, you have to see sigma is divided by j omega epsilon is greater than 1. Therefore, we have to neglect this one. So, j omega epsilon get cancelled. Therefore, gamma is equal to, we have to write it is a root j into root omega into mu. Root j into, what we have to write? Root omega into mu. But root j is equal to, what we have to write? Once you have to see, I is equal to e to the power of I 5 by 2 according to the complex number. Root I is equal to e to the power of I 5 by 4. Root I is equal to e to the power of 5 by 4. E to the power of I theta is equal to cos 5 by 4 plus I sin 5 by 4. Cos 5 by 4 is equal to 1 by root 2 plus I. So 1 by root 2 is there. which is equal to root I is equal. Similarly, root j is equal to what we have to write, 1 by root 2 plus j into 1 by root 2 you have to see. Therefore, you have to substitute here. So, gamma is a propagation constant is equal to 1 by root 2 plus j into 1 by root 2 into root omega into mu. Which one we are writing? Root omega into mu. Therefore, gamma is equal to, you have to substitute here, root omega mu is divided by 2. Root omega mu is divided by 2. You have to take that one. Oh, sigma also is there now. Sigma you have to take here, sigma. Here you have to take the sigma. Root omega into plus j into root omega mu sigma by 2 is there. This is the propagation constant. From this, you have to conclude that what is the, you have to conclude this one, you have to say this one is a phase constant, this one is the attenuation constant. So therefore, alpha is equal to square root of omega mu sigma is divided by 2, and beta also you are getting omega mu sigma by 2 only you are getting. Therefore, which one is the constant? Phase constant and attenuation and phase constant both are equal. Attenuation constants are equal. That is the correct option. Once you have to see. So which one is correct? Phase and attenuation constants are same. We are getting phase and attenuation constants are same for a conductor. Once you have to take the conductor only. For conductor, phase and attenuation constants are same. We are getting the same value. Once you have to see that one. Now the classical mechanics question only. The sixth one you have to see, the following conditions always holds good in a waveguide. This is also waveguide theory, electromagnetic theory only, advanced part, waveguides quoted in your syllabus. It is the advanced part. Nowadays waveguides are very interesting topics also, waveguides also, right? Once you have to see, the following condition always holds the good. So the in the waveguide, you have to take in waveguide, there is a velocities are there, group velocity and phase velocity. You have to take a phase velocity is equal to c is divided by square root of c is divided by square root of omega square minus omega mn square. So this is the dimensions of the waveguide. From this, what we have to write from this formula, omega p is greater than c. Wherefore, what we have to write, the phase velocity is greater than the light velocity in a waveguide. Phase velocity is greater than the light velocity. The phase velocity is greater than the light velocity in a waveguide. So very important. Once you have to see which statement is correct. The statement 3 is correct. The phase velocity is greater than the light velocity. Based on this formula we wrote in under the waveguide. Clear? That is the sixth question under electromagnetic theory. Now we discussed this one. Now you have to see here in a collisionless plasma. So it is also seventh question from electromagnetic theory. Plasma is quoted. It is also electrodynamics, electromagnetic waves, where regions we are discussing electrodynamics, right? Electromagnetic theory only. Seventh question under electromagnetic theory. Clear? In a collisionless plasma, there is no collisionless plasma is there. In a collisionless plasma, when the radio frequency is equal to the plasma frequency, the displacement current means D. The displacement current due to the electromagnetic wave, the displacement current due to the electromagnetic wave equal in opposite to the conduction current. The displacement current in plasma equal to the conduction current, but in opposite direction it will come. That is the theory about the one. Why opposite direction? Because the plasma is made highly excited state, all the electrons are there, that's why the displacement current is in opposite direction only. Theoretical bit you have to remember that one. Now the eighth one also you have to see here, the wavelength of the electromagnetic wave. The eighth one also electromagnetic theory, from which one? Electrodynamics only. Electrodynamics. From electrodynamics only question came, right? Once you have to see the wavelength of the electromagnetic wave produced by a charged oscillator which oscillates about the mean position with the frequency of 300 megahertz. 300 megahertz frequency they are giving. Once you have to see, they are giving the frequency f is equal to 300 megahertz. Mega means 10 to the power of 6 hertz they are giving. The wavelength of the electromagnetic wave, what is the lambda they are asking? What is the lambda? What is the formula? Once you have to see, the formula is equal to c is equal to mu lambda. C is equal to mu lambda. So therefore lambda is equal to c by mu. Lambda is equal to c by mu. Which one we have to write? Lambda is equal to c by mu. C is a light velocity, 3 into 10 to the power of 8. So t into 10 to the power of 8 meter per second, right? Now into, so mu is equal to how much we are getting? 300 into 10 to the power of 6. 10 to the power of 10 to the power of say 8 get cancelled. 3 1 ja 3 1 ja get cancelled. How much we are getting? 1. So 1 meter is the correct option, right? How simple it is there. This question from 6th class onwards, this formula is coming. Once you have to see here. Clear? Now, one of the Leonard-Richards potential. Leonard-Richards potential also is there. This question is the 9th question. Which one it is? 9th question from the electromagnetic theory only. This question is the 9th question from the electromagnetic theory, where it is Leonard-Richards potential is there according to our syllabus. Leonard-Richards potential. Advanced part, Leonard-Richards potential syllabus is there. So what is the Leonard-Richards potential? Two potentials we have. One is a scalar potential, another one is a vector potential. So what is the scalar potential? They are asking V r comma t is equal to Leonard-Richards potential. V r comma t is equal to, which one we have to write here? Once you have to see, V r comma t is equal to Leonard-Richards potential 1 by 4 pi epsilon naught into 1 by 4 pi epsilon naught into QC is divided by RC minus RC minus R dot V. RC minus R dot V. But they are asking in terms of Q only they are asking. Now you have to take the common 1 by 4 pi epsilon naught. This is the formula. QC is divided by C. You have to take here R minus so V by C dot R. So C get cancelled. So therefore Leonard-Richards scalar potential is equal to 1 by 4 pi epsilon naught into Q is divided by R minus R dot V by C is there. R minus R dot V by C. This is the V of R comma T is equal to 1 by 4 pi epsilon naught into Q is divided by R minus R dot V by C. So therefore, what is your option? Your option A is correct. This is also under electromagnetic theory only. Which question it is? Electromagnetic theory only this question came. Once you have to see this Leonard-Richards potential, some vector potentials also is there. Right. So total how many questions came from the electromagnetic theory? 9 questions came from the electromagnetic theory. Now I am coming into the quantum mechanics questions. So based on the your 86th question, this is the 86th question. Total 150 questions are there. Total 150 means from 51 question onwards physics questions are started, because 50 questions from reasoning and arithmetic and teaching aptitude questions are there in TSSET examination. Now you have to see here, this is the first question from quantum mechanics. From quantum mechanics, they are asking in quantum mechanics, whole quantum mechanics, you have to here all those things are there. Vector models. Vector models. You have to take a vector atomic model. From the vector atomic model, So many questions are there. Those questions we have to see here. Clear? What are those questions? Once we have to take, once you have to see a Stern-Gerlach experiment. Which one we are there? A Stern-Gerlach experiment is there. Now you have to see a Stern-Gerlach experiment. A Stern-Gerlach experiment and division and Germer experiment is there. Frank-Hedge experiment and Zeeman effect. The Stern-Gerlach experiment is belongs to the existence of electron spin. This is the third one. The Stern-Gerlach experiment is experimental proof of existence of electron spin. The division and Germer experiment. What is the division and experiment? The division and Germer experiment is the wave nature of the electron. To prove the wave nature of the electron, division and Germer experiment we are using. Frank-Hedge experiment. What is the Frank-Hedge experiment? Quantization of electrons in the atom. That is the 2-1. Quantization of the electrons in the atom. The Zeeman effect is the space quantization of angular momentum. We are taking the Zeeman effect. This is very, very important. Option C. Like this also questions are coming from theoretical. All the basic idea we need, then only we have to do this type of questions. Clear? Now once again you have to see here one more question. If the perturbation energy is proportional to the x cube, this is also quantum mechanics question. The second question also quantum mechanics question. This question came from the perturbation theory. Which theory it is? Perturbation theory. This question came from perturbation theory. Which theory it is? Perturbation theory. Suppose they are giving the perturbed energy h dash is equal to x cube. Then the first order perturbation energy correction of a harmonic oscillator. The first order correction of a harmonic oscillator, psi n is equal to, so for a first order energy psi n 0, psi 0 of x is equal to root which one we have to write is a first order perturbed energy equation for a linear harmonic oscillator. Which one we have to take for a linear harmonic oscillator? Alpha by root 5 e to the power of minus alpha square x square is divided by 2 into hn of x is equal to 1. This is the linear harmonic oscillator. Linear harmonic oscillator ground state energy wave equation. Wave equation, right? But what is the first order energy correction formula? En dash is equal to bra psi 0 of x h dash psi 0 of x ket psi 0 of x. You have to substitute here. So bra psi 0 of x, so x cube into psi 0 of x. If it is odd is there, then you have to take it is equal to 0. So what is that? Your answer is 0. If it is x cube, it is 0. X square it is existing, but x cube you have to take the 0 only. X cube operator you have to substitute in terms of the ladder operators. Then you have to follow this one, that you will get the 0 only you have to get. Clear? That one you have to remember. Quantum mechanics for the perturbation theory they are asking the question. If the lifetime of the state and atom is 2 into 10 to the power of minus 2 second, then the uncertainty is its energy. From Heisenberg uncertainty principle they are asking. It is also quantum mechanics question. From which principle? Heisenberg uncertainty principle. Heisenberg uncertainty principle. Heisenberg uncertainty principle we are asking this question, right? Once you have to see what is that one, once you have to take so they are asking they are giving the lifetime of the state 2 into 10 to the power of n. They are asking about the energy delta E into delta T is equal to h, or h by 2 phi, or h by 2 you have to take delta E into delta is equal to h. So therefore delta E is equal to h by 2 into delta T. You have to substitute. H is a Planck constant. 6.63 into 10 to the power of minus 34 joule second. So 2 into delta T is equal to 2 into 10 to the power of minus 2 so seconds. Then you have to say in terms of the joules is there, 1 joule is equal to 1 by 1.6 into 10 to the power of minus 19 electron volt. So you simplify, you are getting 1.6 into 10 to the power of 14 electron volts. You have to get the answer 1.6 into 10 to the power of minus 14 electron volts, you will get it. Clear? So uncertainty principle you have to apply here. Now one more question you have to see. This is the fourth question under quantum mechanics, right? Fourth question under quantum mechanics. The commutator Lx comma Py, Lx comma Py is equal to, here coming under the commutators. Quantum mechanics, commutators is very important. Which area it is? Commutators area. That area is very important. Once you have to see what is that area, once you have to take here. The commutator Lx comma, the commutator Lx comma Py, Lx comma Py is equal to how much they are asking. What Lx is equal to, you have to substitute. Lx is the operator. Lx is equal to, which one we have to write here? Ypz minus Zpy, Ypz minus Zpy, comma Py. You have to use the linearity property of the commutator. You have to use y into pz comma py commutator, y into pz comma py commutator minus z into py comma py commutator is there. Z into py comma py commutator is there. So then what we have to write here? So you have to take it is a ypy into pz. So minus z into, we have to arrange this py comma py. So therefore py comma py is equal to 0. So commutator ypy xpy is equal to I h cut into pz is there. This is your answer. What is your answer? I h cut into p, I h cut into, you have to take it as a I h cut into pz. Your option is fourth option is correct. Clear? This is the fourth question in the quantum mechanics you have to see. Right, one more question you have to take here. So by coupling the three free electrons, the total angular momentum states they are asking. The coupling the three p electrons are there. This is the first question under atomic molecular physics. Atomic molecular physics, angular momentum. Angular momentum, they are asking angular momentum. In atomic molecular physics, we have to take a angular momentum. What they are asking? 3 p electrons are there. 3 p electron. So 1 0 minus 1. This is 1 p electron, 1 0 minus 1. This one more p orbital, 1 0 minus 1. Suborbitals are there. So 3 electrons are first filled in 3 orbitals. So therefore you have to take a summation of L is equal to 1 plus 1 plus 1 is equal to 3. Summation of S is equal to 1 by 2 plus 1 by 2 plus 1 by 2 is equal to 3 by 2. So therefore the total angular momentum is equal to, total angular momentum is equal to 2L plus 2S plus 1 into 2L plus 1. You have to substitute here. So 2 into 3 by 2 plus 1 into, so 2 into, so which one we have to write? Once you have to see here. So 2 into 3 plus 1. So it is 2 3 just 6 7. 2 2 get cancelled. 7 into 4 is equal to 28. Total 28 means how many states will come? 27 states is there. 27 states. So that the answer is equal to 27. Clear? So that is the answer. Like that you have to calculate. This is the first question in atomic molecular physics. Now the second question, this one also belongs to the atomic molecular physics only. This one also from coupling schemes. Coupling schemes. From the coupling schemes question came. Once you have to see the relation between the magnetic dipole moment and vector angular moment. What is the relation between the magnetic dipole moment? Magnetic dipole moment and vector angular moment minus E by 2m into L. This is the relation between the magnetic dipole moment and vector. This one formula only they are asking. The second one is a correct option. Clear? Because here GL is equal to 1, GL is equal to 1 you consider, then you have to get that one. Mu is equal to minus E by 2m into L we are getting. Clear? Now one more question you have to see. What is that question? Once you have to take according to the first born approximation, the scattering amplitude. First born approximation. This is very, very important. According to the first born approximation, the scattering amplitude is depending upon whom? The first born approximation amplitude formula. This one is quantum mechanics question. This is the quantum mechanics fourth, and this question is the fifth question. They are quantum mechanics question from the scattering theory. Scattering theory. Scattering theory, they are asking. In the scattering theory, Born approximation is there. The first scattering amplitude. The scattering amplitude is equal to, what is the scattering amplitude? F of theta comma phi. F of theta comma phi is equal to minus mu by 2 phi h cut square minus mu by 2 phi h cut square integral e to the power of I q r dash into v of r dash into d of r dash. This is the scattering amplitude formula. The scattering amplitude, where q is equal to, we have to take it as a, where q is equal to k0 minus k, where q is equal to, one more formula is there, so 2k into sine theta by 2. Sine theta by 2. These are the formulas in the scattering amplitude. The scattering amplitude depends on the first born approximation. It depends upon what? You have to substitute these values under q value. You have to substitute. The scattering amplitude can change f of theta comma phi. F of theta comma phi is equal to minus 2 mu by h cut square into q integral 0 to infinite, integral 0 to infinite, you have to take integral 0 to infinite r dash v of r dash into sine r sine q r dash sine q r dash into dr dash. So therefore the scattering amplitude depending upon whom? So depending upon q. Depending upon q means q is in terms of the momentum. So therefore it depends upon the momentum transfer only. It depends upon the momentum transfer only, not initial momentum. Is there any k naught is there? So there is no k naught. Only momentum transfer only it will be happen here. So that is very, very important. The theoretical question they are asking. This is the fifth question under quantum mechanics. Now one more thing you have to see. What is the one more thing? It is also scattering theory only. This one is the sixth question from the quantum mechanics. Sixth question they are asking. In the scattering theory, the optical theorem relates to the total scattering cross section to the dash scattering amplitude. They are asking the optical theory. The scattering theory only. Area is scattering theorem. Area is a scattering theorem only. Correct? In the scattering theory, the optical theorem relates the total scattering cross section to dash scattering amplitude. They are asking dash scattering amplitude. In the scattering theory, once you have to see a optical theorem. What is the optical theorem? The optical theorem is sigma is equal to, the optical theorem sigma is equal to 4 phi by k into imaginary part of scattering amplitude, imaginary part of whom? Imaginary part of f of theta is equal to 0 degrees. F of theta is equal to 0 degrees. This is the, so imaginary part in which direction? It is the forward direction only. So therefore we have to take it as a, the optical theorem is always imaginary part of the forward scattering cross section. This one is sigma is a scattering cross section. Scattering cross section. Sigma is the scattering cross section. Which cross section? Imaginary part of the forward scattering cross section you are getting. If the time dependent perturbation theory, the first order transition amplitude they are asking. Seventh question also from quantum mechanics only. It is belongs to the time dependent perturbation theory. Perturbation theory only. Perturbation theory. Which theory it is? Perturbation theory. That is a time dependent perturbation theory. Formula they are asking. What is the formula? So that formula is equal to time dependent perturbation theory. The first order transition amplitude. The first order transition amplitude AF dash of t. The first order transition amplitude is equal to I h cut all to the power of minus 1, I h cut all to the power of minus 1 into integral. We have to take it as a integral 0 to t. You have to apply the limits, integral 0 to t. You have to take h dash fi fi of t dash fi of t dash e to the power of I omega fi t dash into dt dash. This is the scattering. Which one we have to take? First order transition amplitude. First order transition amplitude for a time dependent perturbation theory. That is the seventh question from the quantum mechanics. Now one more thing you have to see, what is the question you have to take. 95th question you have to take here. It is a Dirac matrices they are asking the question. This is also seventh, means eighth question you have to take. Eighth question number 8 from quantum mechanics only. Which area? Dirac matrices. Dirac matrices is there according to your syllabus. Dirac matrices is there. From that area they are asking the question. The commutator of alpha x alpha y, what they are asking, once you have to see the commutator of alpha x into alpha y into alpha x is equal to how much. First you have to use a, by using the distributive property of the commutator. Commutator AB comma C is equal to, which one we have to write? Commutator AB comma C is equal to A into commutator B comma C plus commutator A comma C into B. Commutator A comma C into B you have to write. Here also you have to say, here same thing you have to apply here. Alpha x into commutator alpha y comma alpha x. So plus which one we have to write here? Alpha x commutator alpha x comma alpha y. Commutator alpha x is equal to 0, it will come. Calculator alpha x in alpha x. So you are getting the 0 one only. Alpha x alpha y you have to get. So what you are getting? Minus 2 alpha y you have to take. It is alpha y alpha x. Sorry, you have to remember this. Alpha y alpha x it will become 0. Alpha x alpha y it will become 0. And you have to simplify. You are getting this one. You have to simplify. You are getting minus 2i1 into alpha y. You are getting minus 2 alpha y. Clear? Because alpha is equal to, I'm giving the alpha x is equal to uh, 0 sigma x 0. Under Pauli matrices we have to write alpha y is equal to, these matrices we call it as a Dirac matrices. 0 sigma y into 0, right? So alpha z is equal to 0 sigma z into 0. So then you have to get, you will get the value. It is a Dirac matrices, right? Eighth question from the quantum mechanics they are asking. Now the major predictions of this one also, ninth question from quantum mechanics only. This one also ninth question from quantum mechanics only. It is also Dirac theory. Dirac matrices are Dirac theory, advanced part of the quantum mechanics they are asking. Major predictions of the Dirac theory for a spin of particles. What are the major predictions are there? So magnetic moment they will ask, and electro spin orbit interaction they will ask, concept of the whole they will explain. All of these is correct. All are all correct. That is all are correct, right? All are right option. Magnetic movement we can explain by using the Dirac theory. Spin orbit interaction we can explain by using the Dirac theory. Concept of whole also we can explain by using the Dirac theory. All are correct. Clear? All are correct. That is very, very important. Now the one more thing is there. Now the hydrogen spectra. This one is already two questions we discussed. Atomic and molecular physics. The first and second questions are there here. Now after atomic molecular physics, 9 questions are there in quantum mechanics. One more question is there. That is the third question from atomic molecular physics, AMP. Which one it is? From hydrogen spectrum. Hydrogen spectrum. You know the hydrogen spectrum. There is a Lyman series, Bauman series, Fashion series, Brackett series, and Fund series is there. Suppose if n is equal to 3, they are asking, suppose you have to say these are the hydrogen spectrum. N is equal to 1. N is equal to 1. You have to take this one is a NF. N is equal to 2. N is equal to 3. N is equal to 4. From 3 you have to take so 3 to 2, the series we call it as a, which series it is Balmer series. In the hydrogen spectra, the wavelength of the spectral line of Balmer series for n is equal to 3. N is equal to 3 means Ni is equal to 3, Nf is equal to 2. Nf is equal to 2, Ni is equal to 3. This is the first Balmer line. So which line it is? First Balmer line. That line we call it as a H alpha line we have to take. For H alpha line, we have to calculate the wavelength. How we have to calculate the wavelength? By using a Rydberg equation. 1 by r is equal to r infinite into 1 by 2 square minus 1 by 3 square. So therefore you have to take it as a lambda is equal to 36 is divided by 5 r infinite. You have to substitute, you will get so how much you have to get it? 6 angstroms you are getting. It is approximately equal to 685. 685, what is that they are giving in terms of meter inverse or angstroms? You have to take 0 angstroms you have to keep. So this is where, or nanometer, they are asking in terms of the nanometer, right? So in terms of the nanometer you have to take, in terms of the nanometer. Clear? Like this formula you have to use from the atomic molecular spectrum, atomic molecular physics. Now the fourth question you have to see. This is also from electronics question. The emitter coupled multi-vibrator design so that the hysteresis is negligible. The circuit referred as a. It is a first question in electronics. ELE, electronics. What they are asking? Multi-vibrators. It is a digital electronics question. Digital electronics. Which electronics? Digital electronics question. A emitter coupled multi-vibrator. Emitter coupled, not digital electronics. In ordinary, transistor, basic electronics only you have to take. Or semiconductor devices. You are taking as a semiconductor devices. Semiconductor devices or transistor application. Transistor applications. Transistor application, semiconductor devices and transistor application. The emitter coupled multi-vibrator is designed so that its hysteresis is negligible. The circuit is referred to as a multi-vibrator. If you have to take a multi-vibrator, you will get the square wave generator only. You have to get which type of wave you have to get for a multi-vibrator? Square wave generator only you have to. Whether it may be a stable and multi-stable, any multi-vibrator if you have to take, square wave generator only you will get it. That is the first question in electronics. Now the second question also under electronics only. Second question also under electronics only, correct? Transistor is a which device? Transistor is a current control device and FET is a voltage control device. So many times in our regular classes we discuss transistor is a current control device. Answer 4 is correct. That is the basic question. This one also application of the transistor, semiconductor devices. This question came under semiconductor devices. Semiconductor devices. This question also came under the semiconductor devices. Transistor is a current control device. Now the third one you have to see. This one also under electronics only. Amplifier, op amp. Op amps, according to your syllabus, op amps is there, correct? So what is the question once you have to see? First they are asking one of the properties of an ideal op amp. Once you have to take a ideal op amp, this very important. Ideal case we want to get in the practical system, right? Ideal op amp. What is the ideal op amp? Once you have to see output impedance. Output impedance of a ideal op amp. Output impedance. So the output impedance of the ideal op amp is equal to how much is there? Infinite. Output impedance is infinite. That input impedance is equal to that input impedance 0. That input impedance of the ideal op amp is equal to how much input in output impedance, sorry, output impedance is 0, input impedance is equal to infinite. Output impedance is 0, input impedance is infinite. Open loop voltage gain or open loop voltage gain. Voltage gain. Open loop voltage gain is equal to what is the open loop voltage gain? Infinite. So these are the characteristics of a ideal op amp. First you have to see infinite output impedance. Wrong, because output impedance is equal to 0. Zero impedance. Zero infinite impedance is not correct. Input impedance is equal to infinite. Next you have to see here zero output open loop gain. Open loop gain is equal to infinite. None of these, because I wrote output impedance, and once again you have to see and you have to remember what is that. You have to see here which one we have to take. Once you have to take for a ideal op amp, output impedance is equal to 0, input impedance is equal to infinite, and open loop voltage gain is equal to infinite, because it is a ideal case. Ideal case, that's why we have to write open loop voltage gain. Open loop voltage gain is equal to how much is there? That is infinite. But here they are giving what they are giving? They are giving 0, but 0 is not correct. Clear? Now one more question you have to take. What is the question number? Question number 3 in electronics. Now you have to take, it is a question number 4. Question number 4 also belongs to whom? Question number 4 also belongs to the electronics only. Question number 4 also belongs to the electronics. In AD converter, the sampling period T should be dash. The sampling, this is the theory only. The sampling period larger than the, so larger than the, it is a AD and DD digital electronics. This area under the digital electronics question came. Which question? Fourth question in the electronics. In AD converter, the sampling period T should be dash larger than the duration of the sample mode and hold mode. Larger than the duration of the sample mode and hold mode, that is the larger one. Clear? Now once again you have to see 100 questions are there, one more 50 are there, because 2 hours onwards I am teaching live. Once you have to see, right? In AC signal conditioning system is used for, this is also electronics question only. Under which one it is? AC conditioning. AC conditioning is belongs to the application of op amp. Application of operational amplifier. In application of a operational amplifier, AC signaling, AC signal conduction conditioning system is used for AC signal. We are using the AC. When we are use the AC signaling condition system is used for a capacitive transducers. Capacitive transducer is correct option. Now the sixth one you have to see. What is the sixth question? Sixth question also from the electronics only. From the electronics. What is that? This is also from the digital electronics only. Digital electronics. Digital electronics also very important. In 8085 microprocessor, we are using a flag resistors. Under the flag resistor, how many number of flip-flops we are using? 8 bit. So 5 flip-flops. 5 flip-flops we are using for 8 bit. For 8 bit. 8 bit flag resistor. For 8 bit flag resistor. For 8 bit flag resistor, how many flip-flops we are using? 5 flip-flop. Each and every flip-flop 1 bit should store. Each and every flip-flop has stores 1 bit. That is very important. 5 is the correct option. Which option is correct? Already they given 5 is correct. That is the digital electronics question. Question number is the 6th from the electronics. Now you have to see a microcontroller. This one also from electronics. Question number 7. This is also microcontroller. Should at least consist of the following. It is also digital electronics. Digital electronics. Microcontroller also come under the digital electronics, microprocessor and microcontroller, right? Once you have to see a microcontroller should at least CPU is there, ROM is there, ROM is there, input output source are there, timer. These are the basic the block diagram of the microcontroller. Microcontroller consists of CPU, RAM, ROM, input port and timers. All the things are existing in a microcontroller. Clear? Now 8th question you have to see. According to your syllabus, set or CSR syllabus, 2 varieties of the syllabus is there. Electronics and experimental methods is there. This question came from electronics only. 8th one, electronics. From they are asking from the experimental methods. Experimental methods asking this question. Once you have to see, if A is equal to 3.56 plus or minus 0.05, A is equal to, they are giving the A is equal to 3.56 plus or minus 0.05 and B is equal to 3.25 plus or minus 0.04 plus or minus 0.04, then value of A plus B they are asking. A plus B is equal to how much they are asking. First you have to see here how we have to calculate. First positive plus values you have to consider. First you have to consider as a plus values you have to consider. Which values? Plus values you have to consider. What are the plus value? A plus B. Plus least value you have to consider. A plus B is equal to, that is the plus value you have to consider. 3.56 plus you have to add 0.05. How much you have to take? Plus you have to consider A. A is equal to, so 1, you have to take 3 point, we have to take it as a, which one we have to consider? 3.61 A if it is plus. If it is minus, if you have to consider A is equal to 3.56, 0.05. You have to take 3.51. You have to take it as a minus if you have to consider. Similarly, plus consider you have to consider for B. B is equal to 3.25 plus 0.04. You will get 3.29. If you have to take the minus, B is equal to 3.25, 0.04 minus you have to consider 213.1. Now you have to add a plus b. A plus b is equal to, plus I am taking plus positive values, 3.61, here 3.29. How much? 096.90 we are getting. Now a plus b, for the least value how to add? For the least value, what is that? 3.51 plus 3.21. 3.51 to 6.72. So therefore our value is existing. So where it is existing, once you have to see 6.7 to 6.90, then you have to see our value is, therefore we have to write 6.72 is less than a plus b is less than or equal to 6.90. 6.90. This is our answer. Clear? Not modulus. A plus b only you have to take. That is the which question number? Question number 8 under electronics only. Question number 8. How many questions are there from the electronics? Electronics also very, very important. Now question number 9 you have to see. Question number 9. The best definition of precision. The best definition of the precision. What is the definition? Speed and accuracy and precision is there. It is also electronics only. Electronics and experimental methods. Experimental methods. Experimental methods. In the experimental methods, electronic experiments are there. Suppose you have to take a calculator. Calculator will give whether it maybe will give the accuracy or not. Accuracy it will go. That is accuracy. So precision missions are there. If you have to take a rolling missions, and if you have to take the motors, there is a precision speed is there. So what is the precision? The precision is a measure of reproducibility of the result. That what is the answer? A measure of reproducibility of the result, we call it as a precision. A measure of the reproducibility of the result, we call it as a precision. That is the 9th question from the electronics only they are asking. There is the 9th question. Clear? Now one more thing you have to see. The distribution used testing a hypothesis is, this one also 10th question from the electronics only. Electronics experimental methods. Experimental methods. Electronics and experimental methods. From the experimental methods this question came. The distribution used for testing hypothesis. Hypothesis, any equipment we prepared, tested, it will be any equipment you have to, any electronic good you have to buy from the market, it tested, it is tested wrote in that equipment. Why? Which principle we are using? By using a normal distribution. Normal distribution technique we are using. That is the 10th question under the electronics only. Now one more question you have to see. What is that? A device that transforms one form of energy to another form of energy. This is also 11th question. 11th question from electronics. Electronics only. Which question it is? 11th question. Which area? Experimental methods. Experimental methods. Which area? This area is experimental methods. Clear? So which device transform one form of energy to another form of energy? So which device we are using? Those devices we call it as a transducers. Whether it may be temperature transducer, pressure transducer, vacuum transducers are there. If you go to the research, you able to know how much pressure we have to apply, how much thing we have to use. All those things we have to learn from that theory. Clear? That is very, very important. A device that transforms one form of energy to another form of energy, we call it as a, which device? That device is a transducer device. Which device it is? That is the transducer device. That is the 11th question. During the Bose-Einstein condensation, this one is the first question under the statistical mechanics. So statistical mechanics, Bose-Einstein condensation is there. during the Bose-Einstein condensation, uh, all the atoms fall back to ground state. This is the theory only. All atoms goes to the ground state. Which state it is? Which area? That is the statistical mechanics area. Clear? Bose-Einstein condensation. All the vapor going into the condensed state. That condensed state is the zero energy state. That is the ground state only. In Gibbs function, G is equal to H minus Ts in thermodynamics in an isobaric reversible process. Suppose if you have to take a isothermal process means which law we have to take it as a isothermal process means temperature is a constant. Temperature is a constant means which one is varying? First you have to see the isothermal process. P1 V1 is equal to P2 V2. This law we call it as a is equal to constant. That is a law. We call it as a Boyle's law. Boyle's law. Which law it is? Boyle's law. Clear? Now you have to see in it is a isothermal. We have to use that pressure and volume is varying. Pressure and volume is a constant. Isobaric you have to use isothermal means temperature is a constant, delta T is equal to 0. Isobaric means delta P is equal to 0. So therefore which law we have to use? V1 by T1 and V2 by T2 is equal to constant. It is this law we call it as a which law? It is Charles law. This law we call it as a Charles law. Suppose if you have to see a reversible process, the third one, if you have to take a reversible process, the reversible process is a slow process. Suppose you have to take the reversible process. Here entropy is a constant. Entropy, you have to take the entropy of the universe remains a constant. Entropy remains a constant, right? And then you have to take a internal energy or internal energy E or U. Internal energy. Entropy and internal energies are constant. So therefore what we have to write? Remains constant but not zero. The Gibbs function is remains constant but not zero, because so Hg is equal to H minus Ts is there. If you have to expand the delta G is equal to Vdp minus SDT plus mu dn, it will come. But any one constant it will come, but it's not zero. If it is isothermal, pressure and volume is existing. If it is isobaric, temperature and volume is existing. If it is a reversible process, entropy remains constant and internal energy remains constant. If you have to consider a dg is equal to which one we have to write? You have to expand that one, vdp minus sdt plus mu dn, right? So anyone it will be constant but not zero. This is the second question from the statistical mechanics. Which one it is? Second question from the statistical mechanics. Which area? Potentials. Potential means Maxwell potentials. Maxwell's potentials. Maxwell potential, 4 potentials are there. Those 4 potentials you have to read, you will get that one. Clear? So now one more question is there, that is the third question. The incorrect thermodynamic Maxwell relations is the incorrect thermodynamic Maxwell relation. This is also statistical mechanics question only, right? Statistical mechanics under thermodynamic potentials or Maxwell equations. Maxwell's equations. Clear? Which one it is? This is the Maxwell equations. What is the, which one is incorrect? 4 Maxwell equations are there. Once you have to see, the first one is incorrect because dou t by dou v at s is equal to minus dou p by dou s at v is there. This one is incorrect one, you have to identify. So this one is correct, this one is correct, but that one is incorrect. This incorrect one is A. Maxwell potentials you have to remember Maxwell equations, you have to remember. Those are the Maxwell equations. Dou T by dou V at S is equal to minus dou P by dou S at V. We want to get it clear. Now, so there is a fourth question. The fourth question also from the statistical mechanics only. So, what is the statistical mechanics? This is the basic introduction of the statistical mechanics, probability theory. So, where we are getting the entropy and probability? What is the relation between the basic thermodynamic probability, probability, right? So what is the basic relation between the thermodynamic probability and entropy? So there is a relation is there. S is equal to K into ln ohm. This is the basic relation between the, this one is entropy. Which one it is? S is a entropy and ohm is the thermodynamic probability. Thermodynamic probability. Which one it is? Thermodynamic probability omega. So there is a relation. How their relation is? The relation is a proportional relation is there. Therefore, the thermodynamic probability is increases with entropy. Thermodynamic probability increases if entropy increases. So entropy increases, thermodynamic probability increases. These are the proportional symbol is there. That is the fourth question from the statistical mechanics. Now one more is there. This one is also fifth question from the statistical mechanics. From ensembles they are asking. Ensemble part is very important. Any competitive exam. So three ensembles are there: canonical ensemble, microcanonical ensemble, and grand canonical ensemble is there. Canonical ensemble is related to thermal equilibrium of the system. Thermal equilibrium. Any ensemble is related to thermal equilibrium of the system. In canonical ensemble, that especially that canonical ensemble, it is a closed system, right? NTV should be varied. This ensemble we call it as a closed ensemble. The system is a closed system. That system we call it as a closed system. Which one is changes? E is changes. Energy is changes in a canonical ensemble. That's why energy changes means thermal equilibrium should be satisfied. Thermal equilibrium of the system is existing in this place, right? That is the fifth question in the statistical mechanics. The number of photons emitted per second by 100-watt bulb which emits the monochromatic light of the wavelength 400 nanometers. This is from atomic molecular physics. From the atomic molecular physics, from laser question came that one. Once you have to see how many atomic molecular physics questions came. I'm checking the atomic molecular physics questions. Third atomic molecular physics questions came. Third atomic molecular questions. Now this one is the fourth one. Atomic molecular physics question is fourth one. Fourth atomic molecular physics question. From which area? From lasers they are asking this question. What is that question? Once you have to see here, once you have to take the number of photons emitted per second by 100-watt bulb. The number of photons emitted by 100-watt bulb, 100-watt bulb is there. Because therefore you have to see the solutions. How we have to write? Power of the bulb is equal to power of the bulb. Power of the bulb is equal to how many watts? 100 watts. This watt is the unit of the power. Therefore, this unit of the power we have to write joule second inverse also. 100 joule second inverse. Clear? This is the power of the bulb. Now, energy of the photon, we have to write energy of the photon. Energy of the photon is equal to energy of the photon is equal to E is equal to h nu. E is equal to h nu is equal to sc by lambda, right? So they are giving the lambda wavelength they are giving. So you have to substitute h is equal to 6.63 into 10 to the power of minus 34. C is equal to 3 into 10 to the power of 8 is divided by lambda is equal to 400 into 10 to the power of minus 9. You have to calculate, you will get one value. So then number of photons emitted per second. How we have to write? number of photons emitted per second. Number of photons emitted per second is equal to, how we have to write number of photons emitted per second is equal to, we have to take a power of the bulb. Power of the bulb is divided by power of the bulb. Power of the bulb is divided by energy of the photon. Energy of the photon. Energy of the photon. Now you have to substitute. Power of the bulb is equal to 100 joule second inverse. Energy of the photon is equal to, you will get that value. You have to substitute. How much value? This is a 4.696969 into 10 to the power of minus 9 it will come. You have to calculate it. So you will get the answer. So 2.02 into 10 to the power of 2.02 into 10 to the power of minus 2.02 into 10 to the power of 20 minus 19 or 20 to the power of 20. 2.2 into plus 10 to the power of 20, we are getting the value. So like this we have to calculate. Once you have to check the answer, 2.2 into 10 to the power of 20 second inverse you are getting. Clear? That is your answer. This is the which question? Fourth question from the atomic molecular physics. Now we are in the statistical mechanics. The sixth question is there. This one is the seventh question from the statistical mechanics. Seventh question from the statistical mechanics. Which area you have to see? It is also from the enthalpy, Maxwell potentials only. Maxwell's potentials. Maxwell's potentials only. We have to take this one. Which one? Your theoretical question. Which of the following statement is correct? Which of the following statement is correct? Delta H and delta S, enthalpy and entropy variations are positive. No, not positive, varying. Delta H and delta S both are negative, not negative. Delta H is positive and delta H is negative, not correct like that. So what is the thing? Once you have to see delta G is 0, then the system is in equilibrium. The Gibbs free energy is equal to 0, then the system is equilibrium. That one is a correct statement. Which question it is? Seventh question under the statistical mechanics. Now once you have to see, it is also from the statistical mechanics. Eighth question from statistical mechanics, from phase space. Phase space is there in the statistical mechanics syllabus, that the continuous phase transition or continuous phase transition is a second order phase transition, is we also call it as a continuous phase transition. The first order is the discontinuity is there. Second order phase transition we also call it as a continuous phase transition. That is the eighth question from the statistical mechanics. Now one more question you have to see. Question is not there here. You have to take Fermi Dirac, means this is the ninth question from a statistical mechanics. They are asking from Fermi Dirac distribution. Fermi Dirac distribution. Three distributions are there: Maxwell Boltzmann distribution, Fermi Dirac distribution, Bose Einstein distribution is there. How many distribution? Three distributions are there: Fermi Dirac, Maxwell Boltzmann, Bose Einstein distributions are there. Under the Fermi Dirac distribution, they are asking the one question. According to Fermi Dirac statistics, the number of ways three particles in distributed in four energy states. What is the distribution formula? The number of ways of a Fermi Dirac distribution is equal to, so WFD is equal to 5I GI factorial is divided by, GI means number of states is divided by number of particles into, so Ni minus GI minus Ni factorial. GI minus Ni factor. Now just you have to substitute. GI is equal to, how many energy states are there? GI is equal to energy states is equal to 4. Ni is equal to 3 energy states are there. Just you have to substitute. 4 factorial is divided by 3 factorial into, which one we have to write? 4 minus 1 factorial. 4 minus 1 factorial is equal to 1. So now 4 into 3 factorial is divided by 3 factorial is equal to, how much we are getting? Answer is the 4. How many energy ways? How many number of ways we have to distribute it? According to the Fermi Dirac statistic, the number of ways 3 particles can be distributed in 4 energy states. How many ways are there? 4 energy ways are there. 4 ways we have to distributed. By using this formula we have to write. Clear? This is the formula. Now you have to take, this is the 9th question from a statistical mechanics. Now when the rotational energy, this one is the atomic molecular physics question. Atomic molecular physics question. Already atomic molecular physics questions are there. Once you have to see here atomic molecular questions. This is the 4th one. Now it is the 5th one. Atomic molecular question, that is the 5th. Each and every paper, how many questions are coming, once you have to see. Area also I am giving. First, this area is Raman effect. Raman effect. Raman effect, because Raman is a Indian scientist. And rotational energy also. Rotational energy also. 2 parts they are included in this question. Raman effect and rotational energy. Once you have to see here. When the rotational absorption spectrum of a diatomic molecule with equilibrium lines with spacing is equal to 20 centimeter inverse, the rotational energy distribution 2b is equal to 20 centimeter inverse. This is the spacing between the rotational energy spectra. Spacing between the rotational energy spectrum 2b. So 2 1 ja, 2 10 ja. Therefore, rotational constant is equal to 10 centimeter inverse. We are getting 10 centimeter inverse. Now, then the position of the first Stokes line in the rotational Raman spectrum. Suppose you have to observe the rotational Raman spectrum. This is the main line. This one is a first Stokes line. This one is the first anti-Stokes line. 6b is there. From 0 to here, how many distance is there? 6b is there. So therefore, the first Stokes line, Stokes line is equal to, which one we have to write? 6 into b. So therefore, b is equal to, now only we discuss t, 10, 6 into 10, 10 centimeter inverse. So what is your answer? 100 is not correct, 120 is not correct, 140 is not correct. Go for the one more answer. What is that? 60 centimeter inverse. Like this we have to calculate. How simple it is once you have to see. In CSIR examination also people are asking like this question. This question they are imported from the CSIR only. We clear? That is very, very important. Like these questions will come in your competitive exam. One more 30 questions are there, because now we are 119 only. Now the natural line width of the spectral line emission spectrum of an atomic state, the with lifetime 10 nanosecond. What is the order they are asking? What is the order of the lifetime they are asking? Once you have to see here. uh, Once you have to take how we have to calculate the order of the lifetime. Once you have to take delta nu. It is also atomic molecular physics question only. From the laser part they are asking. Atomic molecular physics, the 5th question. This one is a atomic molecular question, atomic molecular physics. From the natural line width of the spectral line widths are there. Broadening of the spectrum or line widths. Spectral line width, spectral line widths are there. According to the laser also is there. The natural line width of the spectral line in the emission spectrum of the atomic state, the lifetime is 10 nanoseconds. Lifetime they are giving. What is the lifetime? 10 nanoseconds lifetime they are giving. Tau is equal to 10 nanoseconds. The lifetime of the 10 nanoseconds they are giving. If the order of the natural line width of the spectral line in the emission of an atomic state with lifetime 10 nanoseconds of the order of. So which one they are asking? The emission spectrum order they are asking. The natural line width is equal to delta nu they are asking. Once you have to see uncertainty principle, delta E into delta tau is equal to H. You have to take, or H by 2 5 you have to consider. So delta E is equal to H nu you have to write here. Which one we have to write? Delta nu is equal to H nu you have to take, correct? H into delta nu into delta tau is equal to H by 2 5. So H get cancel, you have to cancel it. Delta nu, this is the line width of the spectral line, is equal to 1 by 2 5 into the 1 by 2 5 into delta tau. Now you have to substitute 1 by 25 is equal to 3.14 into 10 to the power of minus 9 nanosecond. If you calculate how much you are getting the value, 10 to the power of minus second you have to take it is a joules, you have to convert it into the electromagnetic 1 joule is equal to, that energy is in terms of the joule it will come, right? So in terms of the energy you have to write 1 joule is equal to 1.6 into 1 electron volt is equal to 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. 1 joule is equal to 1 by 1.6 into 10 to the power of minus 19 joules you have to take. So you will get that answer 10 to the power of minus 7 electron volts you are getting. Clear? So that is very, very important. H by you have to take it as a just simply not like that. Just you have to simple way you have to see how you have to get that one also I will give to you. Not this one. You have to follow one more also you have to follow. Uh, if you have any doubt you have to follow one more thing you have to follow. So what is the nanoseconds are there, just you have to follow. So how you have to follow, delta E is equal to h nu, delta E is equal to h nu or delta h nu you have to substitute delta h nu you have to take, right? From this you have to substitute which one you have to substitute, delta E into delta T is equal to h by h you have to take Einstein Heisenberg uncertainty principle, delta E is equal to h by delta T you have to write because energy only they are asking, correct? Now you have to substitute h is equal to 6.623 into 10 to the power of minus 34 joule second, T is equal to 10 to the power of 9 into 1 joule is equal to 1 by 1.6 into 10 to the power of minus 19. Now you will get 10 to the power of 7 electron volt you have to, 10 to the power of minus 7 electron volt you have to get in terms of the order you have to take. This is the sixth question from atomic molecular physics. Now this one also atomic molecular physics only, right? This one is the seventh question from atomic molecular physics. What is that? Seventh question from atomic molecular physics. If the energy of the first excited state of the rigid rotator is 1.55, what is the rigid rotator is equal to J is equal ER is equal to J into J plus 1 into J in energy of the spectrum, J into J plus 1 into h cut square by 2 2I. This is the moment of inertia. That is the first. If J is equal to 1, you have to take it as a J is equal to energy levels. You have to consider the first energy level is J is equal to 0, the first excited state, and the second excited state, and the third excited state you have to consider. If the energy of the first excited state of the rigid rotator J is equal to 1, E1 is equal to what we have to write, first excited state is equal to which one we have to write, 1 into 1 plus 1 is equal to 2 h cut square by 2i. So 2 h cut square by 2i is equal to how much we are getting, 1.5 milli electron volt we have to get. So which is equal to 2 h cut square is divided by 2i is equal to, correct? Now they are asking of the third excited state, first excited state, second excited state, third excited state they are asking. Third excited state is equal to E3 is equal to which one we have to write, 3 into 3 plus 1 into h cut square is divided by 2i. So then we have to write 3 into 4. 3 into 4 into h cut square is divided by 2i. Already we know 3 into 2 into 2 h cut square by 2i. This 2 h cut square by 2i for first excited state I am taking 6 into 1.5 milli electron volt. 6 into 1.5 milli electron volt is equal to 6 into 1.5 is equal to how much we are getting, 9 we are getting. Like this we have to calculate. That is very, very important one. Like this we have to see. 6 into 1.5 is equal to how much? This is the 9 milli electron volt. Based on the formula, I did this one. Because I am teaching the fast, because 200 of hour onwards, I am teaching continuously. No one can teach like this because it is a live class. 100 questions I want to teach to you. All TSSET 2023 question paper I am discussing to you. Whether a paper, how it will come after listening, I will see. Then you have to see chemical shift. This is the 8th question from atomic molecular physics. 8th question from atomical molecular physics. So there is a shift is there, chemical shift due to the electron shielding. Theoretical question only. Chemical shift arises due to a electron shielding only. Chemical shifts there will arise. Now the coupling schemes only they are getting. If the possible transition presence of the weak magnetic field, there is a presence of the weak magnetic field. Once you have to see 2p 3 by 2 to 2s 1 by 2. So 2p 3 by 2 to 2s 1 by 2. This is a sodium D2 line. Which line it is? Sodium D2 line. In the presence of the weak magnetic field, already we know sodium D2 line. In the presence of the weak magnetic field, how many spectral lines which arises because of the selection rule delta mj is equal to 0 comma plus or minus 1. If you have to apply, so D2 line 6 lines it will happen, 6 lines. Otherwise you have to go for, you expand the 3p2 and 2s 1 by 2, you have to draw that. So p3 by 2 can converted into how many so spectral lines it will be converted. Once you have to see here, so minus 3 by 2, minus 1 by 2, 1 by 2, 3 by 2, you have to see minus 3 by 2, minus 1 by 2, 3 by 2 if you have to take, right? Otherwise you have to consider as a plus plus minus minus, you have to take, right? So now you have to see s 1 by 2, it is divided into two parts because it is mj values, mj values. So plus 1 by 2 minus 1 by 2, you have to draw the spectral lines by using a delta mj is equal to 0 plus or minus 1. You have to take 1 by 2 to 1 by 2, one line is there, minus 1 by 2 minus 1 by 2, delta mj is equal to 0, two lines is existing. Now you have to take minus 3 by 2 to minus 1, minus 3 by 2 to you have to take plus 1 by 2 to minus 1 by 2. Now 1 by 2 to minus 1 by 2, you have to take 1 by 2 to minus 1 by 2. Now 3 by 2 to 1 by 2, you have to take 3 by 2 to 1 by 2. Delta mj is equal to plus 1. Delta mj is equal to minus 1 combination, you have to see minus 3 by 2 to 1 by 2. Minus 3 by 2, 1 by 2, one combination you have to write minus 3 by 2 to 1 by 2. And next one more combination you have to write here. So how we have to get the, now you have to see 1 by 2, 1 by 2 minus 1 by 2, you have to take it as a minus 1. How we have to get minus 3 by 2 minus 1 by 2, minus 1 we are getting minus 1 by 2 minus 1 by 2, minus 1 by 2 minus 1 by 2, you have to take minus 1 by 2 minus 1 by 2 minus 1 by 2, right? So you are getting the values. This is the delta j is equal to mj is equal to minus 1. Total how many? Total 6 lines are there. 6 lines is existing. It is a sodium sodium transition lines under the weak magnetic D2 transition. That is the D2 transition under atomic molecular physics only. This one also atomic molecular physics. Question number 9. Question number 9, atomic molecular physics. Which area? It is a Zeeman effect. Zeeman effect. Zeeman effect. Zeeman effect is under weak 8th question you have to see, right? Now 10th question under atomic molecular physics only. 10th question you have to see. It is a molecular spectrum. Molecular spectra. Molecular spectra. What is the rotational energy? Er is a rotational energy, ev is the vibrational energy, et is a translational energy, and e is the electronic energy. Which energy is greater? Once you have to see, electronic energy is greater. This energy value is 1 to 10 electron volts is there. Next, vibrational energy 10 to the power of minus 1 electronic energy electron volt. Next, rotational energy, this is the 10 to the power of minus 3 electron volts. Next, smallest is the translational energy is there. That is the order of the energy energy variations, order of the energy variations, you have to take that one. Clear? Now we have to see the one more question. In gyromagnetic ratio is the ratio of, gyromagnetic ratio is the ratio of whom they are asking. In a gyromagnetic ratio, GL is equal to, is the ratio of magnetic moment is divided by orbital moment. Magnetic moment is divided by orbital moment. This is the formula for a gyromagnetic ratio, is the ratio of the spinning of a charged particle magnetic moment to the orbital angular momentum, magnetic moment to the orbital angular moment, magnetic moment to the angular momentum. Clear? That is the option is correct. Now which question that is? 10th question under atomic molecular physics. Now the 11th question, it is also very very important from atomic molecular physics only. Which area it is? Zeeman effect. This area is a Zeeman effect. Once you have to see the normal Zeeman effect. Now I gave the anomalous Zeeman effect selection rules. A normal Zeeman effect delta ml is equal to 0 comma plus or minus 1. This is the selection rule for a normal Zeeman effect. What is the selection rule for the normal Zeeman effect? Delta ml is equal to 0 comma plus or minus 1 is the normal Zeeman effect selection rule. Clear? 11th question from atomic molecular physics they are asking. Now one more question you have to see. It is also atomic molecular physics only. 12th question from atomic molecular physics. From lasers they are asking. From lasers. In Einstein coefficients, Einstein stimulated emission coefficient and stimulated absorption coefficient. Stimulated emission coefficient and stimulated emission coefficient and absorption coefficient. Both are stimulated. What is the relation between them? So B12 is equal to Einstein. B12 is the Einstein stimulated absorption coefficient is equal to B21 Einstein stimulated emission coefficient. This is the relation between the B12 is equal to B21. It is very very important. How simple they are asking. Einstein coefficients from laser part they are asking. This is the 12th one. Now you have to see 13th question. The 13th question also from the atomic molecular physics. It is also from the lasers only. The 13th question also coming from the lasers only. What is they are asking? The coherence length of the sodium yellow light is they are giving in 10 to the power of minus 10 pulse duration. What is the coherence length they are asking? The coherence length is equal to, the coherence length is equal to, it is very very important. Coherence length is equal to, which one we have to write? Sodium light yellow light, what is the coherence length of the sodium light? Yellow light is equal to 5893 angstroms. The coherence length is equal to formula C into time duration. Coherence time. Coherence time. C is equal to coherence time is there. So therefore what they are asking? So they are asking about the, they are asking about what they are asking. The coherence length they are asking. C into 3 into 10 to the power of 8. So into 10 to the power of minus 10. 10 to the power of 8 into 10 to the power of minus 10 is equal to T into 10 to the power of minus 2. Coherence length is equal to, in terms of meters we are asking. How simple it is. So this data is not used, but they are giving the, to confuse you, they are giving this data. So which one, which is the formula? Coherence length is equal to C into coherence time. Coherence time. Just you substituted in that formula, you will get the answer. Clear? Now 13th over a point of, now 13 questions are there from atomic molecular physics. It is very very important. Now SSP questions are started, that is the condensed matter physics. Condensed matter physics. So lattice, reciprocal lattices are there. Which area it is? Reciprocal lattices. Condensed matter physics. Which area it is? This is the reciprocal lattice area. Clear? So a point in reciprocal space represent in real space is, we call it as a plane. That is a theoretical question. What is the definition? A point in reciprocal space represent in real space is a plane. That is the question from condensed matter physics. CMP means condensed matter physics. Now you have to see here, match the following. Crystal, it is also second question from condensed matter physics. Second question from condensed matter physics. What is that question? Crystal systems. 7 crystal systems are there. Simple cubic, monoclinic, triclonal, triclinic, orthorhombic, monoclinic. 7 crystal systems are there. In the 7 crystal system, you have to see here. For a monoclinic, their relations are there. The first one you have to see. Monoclinic is belongs to the R. Monoclinic means A is not equal to B is not equal to C, alpha is equal to beta is equal to 90 degrees, but not is equal to gamma. And tetragonal it is belongs to the S. A is equal to B is not equal to C, alpha is equal to beta is equal to gamma is equal to 90 degrees. For the rhombohedral, you have to see what is a rhombohedral. That is the P1. A is equal to B is equal to C, alpha is equal to beta is equal to gamma is not equal to 90 degrees. For a orthorhombic, that is belong Q, A is not equal to B is not equal to C, alpha is equal to beta is equal to gamma is equal to 90 degrees. That is the which one it is? That is crystal systems definitions they are asking based on the crystal systems. The second brilliant zone. So now this is also third from brilliant zones, condensed matter physics, chronic model, chronic penny model. Chronic penny model is there. From the chronic penny model, what is the second brilliant zone range? First brilliant zone range is different, and the second brilliant zone range is equal to how much the second brilliant range? So this one is a second brilliant zone range, minus 5 by a to minus 2 5 by a, and plus 5 by a to plus 2 5 by a is the second brilliant zone range, right? Now condensed matter physics third question is completed. Now one more thing is there. This is also fourth question from a condensed matter physics. From which area? Free electron theory. Free electron theory, Lorentz free electron theory, Joule Lorentz free electron theory. Free electron theory, Joule Lorentz free electron theory we are taking. According to the Joule Lorentz free electron theory, what they are giving once you have to see here. The drift velocity of the free particles is with mobility is equal to mobility they are giving mobility is equal to 1.5 into 10 to the power of minus 3 meter square per volt, and the electric field strength is equal to E is equal to 0.5 volt per meter. What they are asking, drift velocity is equal to how much they are asking. What is the formula for the drift velocity? Drift velocity is equal to mu into E. Just you have to multiply these two. 0.5 into 1.5 into 10 to the power of minus 3. 0.5 into 5 is equal to, so what we are getting? 0.75 into 10 to the power of minus 2 meter per second. This is the drift velocity you are getting. How simple it is once you have to see. You are getting from the condensed matter physics. Clear? Now one more question you have to get from the Hall effect. Hall effect also from the condensed matter physics only. Hall effect is there according to your syllabus. Hall effect is there. This is very important effective once you have to see. If the Hall effect coefficient is Hall coefficient RH is equal to 3 centimeter cube by C charge carriers, and carrier mobility is mu is equal to 3 centimeter square per second, then the conductivity is equal to how much they are asking. What is the relation between the RH, mu and conductivity? So there is a formula is there. Mu is equal to sigma into RH. Mu is equal to sigma into RH. What they are asking? Conductivity is equal to mu by RH. You have to calculate in that formula. So you are getting the option. What option you have to get once you have to see? Mu is equal to 3 centimeter cube is divided by C. 3 centimeter cube is divided by C, and RH is equal to 3 centimeter square is divided by S. Right? Now you have to say what we have 3 get cancelled. Now 1 centimeter square, centimeter cube is there. Now RH is equal, mu is equal to, here you have to take centimeter cube. So therefore what we have to take here 1 into S by centimeter. 1 into S by centimeter means in terms of the meter, how it will come? 1 centimeter is equal to 10 to the power of minus 2 meters it will come. So therefore, if you have to convert, you will get 0.001 centimeter per second you have to take. 0.001 centimeter per second you are getting. That is very, very important one you have to see. Or otherwise one you won't get. All the options are mismatch is there. You have to see that one. Centimeter you have to convert into 10 to the power of 1 centimeter is equal to 10 to the power of minus 2 meters. If it is goes to the 10 to the power of 100 we are getting actually. The some option wrong options is there. We have to get 100 S by m. 100 S by m. This is the cubic is there, no? This cubic also if you have to convert, what will happen? 100 by cubic. Oh, correct. 100 by cubic is equal to 10 to 10 cube is there. 0.1 it will come. Correct. 0.1. Which one we are getting? 0.1. Second option is correct. 0.1 for cubic. For cubic means so cubic centimeter means 10 to the power of 3 we are getting for cubic. 10 cube we are getting. So therefore 10 cube means 100 by 10 cube you are getting that one. You have to take it as a 1 by c 10 cube. You have to get 1 by 10 means 0.1 S by m. Clear? 0.1 S by. Fifth question from condensed matter physics. Fifth question from condensed matter physics. Now the sixth question also belongs to the condensed matter physics only. From which area? The crystal systems only here. This also crystal systems. Crystal system only. Hexagonal closed pack and FCC packing factor is equal to same. Hexagonal and hexagonal and FCC both are closely packed systems. So 0.74 and 0.74 both are same. That one is correct. That is the sixth one. Now the seventh one you have to see the binding energy of the Cooper pair. That the seventh one semi superconductivity, condensed matter physics. From the superconductivity they are asking this question. Superconductivity, condensed matter physics from superconductivity. What is the order of the Cooper pair? Energy of binding energy of the Cooper pair 10 to the power of minus 4 electron. Milli electron volt is order is a milli electron volt. They are taking as a one more 10 to the power of minus 4 is more predominant to that one. Now once again you have to see this one also same thing. Seventh question already 7 is there. Eighth question from condensed matter physics only. This is a Bragg's law means crystal diffraction. Now diffraction phenomena is there. From that we have to take 2d sin theta is equal to n lambda. Then you have to read X-ray beam of wavelength 0.1 nanometer. Wavelength is equal to 0.1 nanometer into 10 to the power of minus 9. And angle is equal to how much it is? The theta is equal to 30 degrees. And diffracts in the first order n is equal to 1. Then separation d is equal to how much they are asking. Just you have to substitute, you will get the answer. 2d sin 30 is equal to 1 into lambda is equal to 0.1 into 10 to the power of minus 9. Now sin 30 is equal to 2d into sin 30 is equal to how much? Sin 30 is equal to 1 by 2, correct? 2 get cancel is equal to 1 into 0.1 into 10 to the power of minus 9. Therefore d is equal to 0.1 nanometer. What is the plane separation? How much is there? 0.1 nanometer. Like that we have to do. 0.1 nanometer is the plane separation. That is the 8th question from the condensed matter physics only. Now this one is the 9th question from condensed matter physics only. 9th question also from condensed matter physics. Energy densities. Energy densities is very, very important. Energy densities. They are asking this. So the number of density of the free electron gas in 3 dimension if you have to take is increased by the 8 times. 8 times energy density n is increased. N is equal to 8 times is increased. Then the Fermi temperature is equal to. the Fermi temperature is directly proportional to the energy density of 2 by 3. So therefore, the Fermi temperature is directly proportional to 8 times means 2 cube is divided by 2 by 3, cube get cancelled. The Fermi temperature is increased how many times? 4 times increases. This is very, very important. So many times in CSIR also this question came. In CSIR and GATE also this area is very, very important. So the energy densities in 3 dimension is different, 2 dimension is different, in 1 dimension is different, but that is very, very important to one you have to see. Clear? Right. Now we are ending that one. That's why we have to going fast. Now already electronics, so many questions are there. This question also from the basic electronics only came. Once you have to see the last question in the electronics, you have to take Amp 11th one. Electronics questions, I am searching for the electronics one. You have to see how many questions are there from the electronics. Electronics 11th question we stopped. Now we have to take here 12th question. 12th question from electronics. Which area? Semiconductor physics. Semiconductor devices. In semiconductor devices, transistors are there. In the transistor, it is the emitter, base, collector is there. What is the voltage? They are asking about uh, in the circuit shown, the output voltage is equal to. The output voltage is equal to. Now we have to take the ground. Ground we are connected to here. That output voltage is equal to 0 volts. How many volts are there? The output voltage is equal to 0 volts is there. Answer 0 is correct. Now we have to take it is a condensed matter physics only. Now you have to 9th condensed matter. This one is the 10th question from a condensed matter physics. 10th question from condensed matter physics. Which area it is? Quasi crystals. Quasi crystal. Quasi crystal. They are giving the two statement. One is a statement, another one is a as a reason. What correction reason they are giving. Once you have to check it. A quasi crystals form when the certain molten alloys cool very slowly. Quasi crystal, how it will form? When certain molten alloys cool slowly. That is the assertion, is statement is correct. Why? Reason they are giving. Quasi crystals have short range as well as their long range order in their arrangement. Once you have to see the answer, the assertion as well as the reasons are correct, but the reason is not the correct explanation of the assertion. Assertion and reason also correct, but reason is complete, not complete expression, because long range order possess every time. Short range order also possess every time. That is a, there is a problem is there. So that is the thing once you have to remember. Now we are coming under to the nuclear physics. This is the first question from nuclear and particle physics. I am taking as a nuclear and particle physics. Which area? Nuclear forces. Nuclear forces. I am coming into the last topic because so many topics I discussed, all variety of the topic. How many topics I am discussing from 3 hours onwards? 3 hours completed. 3 hours onwards I am teaching the live class. From 3 hours onwards I am teaching the live class. Please utilize this chance. All the papers I told, now under the last paper I am giving only 11 questions are there. These 11 questions if we take, we will finish this one. Within the short period I have to finish. Once you have to see. The Majorana force is the dash force. It is a nuclear force. Which force it is? It belongs to the space exchange. Space exchange force, we call it as a Majorana force. It is a nuclear physics. First question. The second one you have to see the diameter of the atom and nuclear forces of the order of. The diameter of the atom is equal to 10 to the power of minus 10. The diameter of the nucleus is equal to 10 to the power of minus 15 meters, because it is the Fermi. Fermi, in the order of the Fermis, right? That is a theoretical question only. This one also nuclear and particle physics. Nuclear and particle physics. Nucleuses. Nuclei. Nuclei, you have to write nuclei. Right? Now once you have to see the second one, this is the second, not second one, third one, nuclear and particle physics. Nuclear and particle physics. If the half life of the radioactive material is 24 days, if 8 grams of this isotope is present initially, then the atom remains after 72 days. What happen? How we have to calculate? This is very very important. Like these questions will get in your competitive examination also. Once you have to see log x by x0 is equal to log x by x0 is equal to k into t. This is one formula for a where a logarithmic constant, decay constant k is equal to, what we have to write, decay constant k is equal to ln2 is divided by t of ln2 is divided by t of. But k you have to first you calculate the k value. ln2 is divided by, if the half life of the radioactive decay is equal to 24 days. So in terms of the days I am writing, if 8 grams of the isotope is present initially how many grams are there? 8 grams are there. Presently, initially 8 grams are there, right? X is equal to 8 grams. The amount of the remain after 72 days, what is going to happen? After remaining 72 days, what is going to happen? You have to see. First, you have to substitute here log x is equal to 8 is divided by x square is equal to k into ln2. ln2 is divided by 24. How many days? After 72 days. 24 1 ja, 24 3 jas. 24 1 ja, 24 3 jas. 3 ln2 is equal to log 8 by x0. Log 8 by x0. Now you have to take here what will happen? You have to simplify. Log 8, log 8 by x0 is equal to ln2 cube. ln get cancelled. 8 by x0 is equal to 2 cube. So therefore x0 is equal to 8 by 8. Therefore x0 is equal to 1. How much you are getting? 1 gram. How much? 1 gram you are getting. Clear? This is like this we have to calculate. This is the third question from the nuclear and particle physics. Radioactive decay. Radioactive decay. This question came from the radioactive decay. Clear? Now one more question you have to see. What is that question once you have to take? Nuclei having the same number of neutrons. If it is same number of neutrons, we call it as a isotones. Which is the answer? Isotone is the correct option. This question is question number how much? Question number fourth question under nuclear and particle physics. It is from isobars, isotones. It is also coming under the nucleons only. Nucleons. The first class itself only I told. Now a free neutron decays into a proton. Decay products of the electron and other. What we have to take? A free neutron decays into the proton. It is the electron plus anti-neutrino plus some energy it will be released. This is the option. The fifth question. Nuclear and particle physics. It is a nuclear decays. Nuclear decays. What is the area? Nuclear decays. Alpha decay, beta decay, gamma decay. From this electron decay means beta decay. Which one it is? Anti-neutrino is arises. Anti-neutrino. Clear? Now question number is fifth one. Now question number sixth one. Nuclear forces have the strength in the order. Proton stands for the P stands for the proton. N stands for the neutron. Then you have to write what is the nuclear forces only. Nuclear forces properties. The sixth question. This one is the sixth question. Nuclear and particle physics. Nuclear forces properties. Nuclear forces properties. This one is nuclear forces property. What is this? Nuclear forces are nuclear forces are charge independent. Charge independent. Nuclear forces are charge independent, right? If nuclear forces are charge independent means proton, neutron. So neutron, proton, neutron is equal to proton neutron, because it is not depending upon the charge dependent. So that's why the same force can arises. Nuclear forces are charge independent. That is the property. Now the seventh question in the nuclear physics and particle physics. Seventh question, nuclear physics and particle physics. What is that question? Yukawa potential. Yukawa potential, nuclear potentials. There is a topics are there. Nuclear potentials. Yukawa potential. What is the Yukawa potential? Yukawa potential, VR is equal to e to the power of minus AR is divided by R. This is the Yukawa potential. How it will be there, Yukawa potential? If you have to draw here, once you have to take R in x-axis and V in y-axis minus V, you will get the potential. This potential is Yukawa potential. That is your Yukawa potential, that one. Now the eighth question from nuclear and particle physics only. Eighth question from nuclear and particle physics. A surface energy in the semi-empirical mass formula. Semi-empirical mass formula. Semi-empirical mass formula. It is a liquid drop model. Nuclear models. Which topic it is? Nuclear models. Right? In semi-empirical mass energy, binding energy, the surface a to the power of 2 by 3 is always directly proportional to a to the power of 2 by 3. Which option is correct? Option C is correct, right? A to the power of 2 by 3 is correct. Now you have to say, which is this one also, nuclear physics only. Eighth, ninth one. Ninth one, nuclear and particle physics, right? Nuclear and particle physics, which area? It is a binding energy. There is a binding energy is the area is there, right? Before the binding energy, there is a mass difference is there. Suppose you have to take a nuclear masses, you have to consider as a x, z, a, you have to consider this is a nuclei. If you have to take a nuclei, how we have to write the mass of the nuclei is equal to z into mp plus a minus z into mn. This is the mass of the nucleus. Suppose if you have to take a real mass, m you have to consider as a real mass of the system. So therefore z into mp plus a minus z into mn, always greater than the mass of the real mass of the nucleus. So therefore what we have to write? M is less than z into a minus z into mn plus z into mp. This is the correct one. You have to take that one is the correct one. Clear? This is the mass defect. Mass defect. Binding energy. Because of the mass defect only atom bombs and hydrogen bombs and energy should be produced. How many questions we are getting? 9 questions. This one is the 10th question from nuclear and particle physics only. We got strangeness is converted to strange particle. Suppose lambda is a strange particle, summation is the strange particle, right? Like these particles will give the strong decay, strong interactions they will give. Strange particle, it is a particle physics. Particle physics, this will come under the particle physics. What we have to write? Strangeness particle, only 5 particles are there. The strange particles will give the strong interaction but not interaction. If it is there strange particle decay, the strange particle decay will give the strong interaction. That is the area of the system of nuclear particle decay. That is the particle one. Now 11th one, nuclear physics and particle physics. The 11th question once you have to see nuclear fission. Nuclear fission, it is a liquid drop model. Liquid drop model. Liquid drop model, from where we are getting the liquid drop model? Because of the nuclear fission only we are getting the liquid drop model. In last exam also they are asking in JL 2019 to 23 TSPSC people also asking this question. So liquid drop model, because of the nuclear fission only liquid drop model is arises. And last question, this is the 150 question is there. A neutron is composed of, this is the baryon number. Baryons are 2 varieties of the baryons are there. Spin 1 by 2 baryon, spin 3 by 2 baryon is there. Suppose if you have to see the spin 1 by 2 baryon, what are the spin 1 by 2? Proton and neutron. If you have to take a spin 1 by 2 baryon, proton and neutron, and lambda 0, summation plus, summation 0, summation minus, cascade 0, cascade minus, cascade minus. These are what? These are a spin-off baryons. Spin-off baryons you have to take. Spin-off baryons. How we have to write the structure of the spin-off baryons once you have to see the structure of the spin-off baryons once you have to take. How we have to write the structure of the proton and neutron, and lambda 0, summation plus, summation 0, summation minus, cascade 0, cascade minus. These are the particles. How we have to write once you have to see? You have to take a proton, you have to take here, neutron you have to take here, summation plus, summation 0 and lambda 0, summation minus you have to take here, cascade 0 and cascade minus you have to take. Now you have to write the right here, you have to take here ud. There is a up and down is there. First you have to come to here u up. So d, yes, you have to keep. Now you see the opposite side, which is the missing letter you have to keep here. What is the missing letter here? S is missing letter you have to keep. You see the opposite side, which is a missing letter, u is a missing letter you have to see. You keep the opposite side, which is the missing letter. Missing letter is which one? D is the missing letter. Now that they are asking, neutron is composed of UDD. U means one up particle is there, one up particle, right? U means one up particle. DD means two down particles are there, two down particles, one up particle, two down particles are there, right? So that is the thing. Neutron is composed of whom? So neutron structure is one up quark and two down quarks are there. That neutron is composed of UDD. Neutron is composed of UDD. Clear? So these are the 150 questions. For 150 questions I told. So I will explain maybe 3 hours 16 minutes. So no one can teach like this. 150 questions, no one can teach. I told all the areas. So this question also, from which area it will coming? Nuclear and particle physics. Nuclear and particle physics. 12th question, nuclear and particle physics only. From which area? Nuclear particles area they are asking this question. Clear? Now once again I'm informing to you, we started the CSR course. If we really like our teaching to you, no one can teach like this. All the papers no one can teach. Wherever you go, in Delhi, Hyderabad, wherever you go, people will come, one paper will teach. Here all papers I only will teach, right? We are expertised in to give the CSR coaching. Please utilize this chance. I am requesting you, you have to join. If any doubt you should ask me. If you want to negotiate, you have to negotiate with me, but you have to take the long term preparation. At least 1 year preparation you have to take. Within 6 months I unable to finish the course. Once after finishing this course, already will be online mode. That's why you have to able to listen. One day also you have to listen. Maybe more than 1,000 hours I have to teach to you, right? So already I am taking these courses, already I am giving into you DL physics and JL physics and DSC physics content and GS physics content we started. Thank you for your listening patiently. Wish you all the best. Next month 11th onwards, next month means September 11th onwards, there is a set examination is going to happen in Telangana. That's why I taught all the areas. So whatever these areas are there, these areas you have to see. Otherwise you have to listen my video, these 3 hours video. It will help you in your writing exams in future set examination. All the best. So once again, I'm requesting you, please share and subscribe our YouTube channel. We will come with nice videos, nice content in physics and current affairs daily also. Thank you very much. Thank you once again.